go. Yeah, and the fact that this whole streaming thing works, like,
Yeah.
you know, I when I think about all of the bits flowing around the world, right? It's hard to imagine that this actually works.
I think I mentioned this one other time. Now, keep in mind, my boss was the IT manager. And one time I was like, it's you have to stand back and think of this. Every single thing that the computer does is broken down into ones and zeros, just all over the place. And she's like, nah.
Oh, Jesus. Oh,
Yeah.
yeah, always nice when you have an IT manager who doesn't actually know how technology works. Yeah, it's not little hamsters that are running around in your computer that are, you know. Okay, so today, you know, I would love to give everybody a vote, but you know, I could model my heart away day after day after day, and it would not move the needle in the mod because you actually have to work to implement that stuff in order for it to work. So code is about 80% of the mod. Okay, so if you're playing the mod, if you're enjoying the mod, I very much appreciate it. But just know that 80% at least of the work involved is code that actually makes everything do a thing, right? Otherwise, it's just a pretty thing that you can place in the world, and you know, something that doesn't do anything. So yeah, it is what it is. We're gonna work on it here, but we're not gonna work on the distillation tower. As I said in my last stream, the feature that I need to work on here is the pipes network, and I haven't really gotten anything done since the last stream. I have been hard at work on my Europa Universalis mod for EU5, and that finally went out yesterday or the day before. I think, yeah, 2 days ago I put it out, and yesterday I put out an update because I was playing in my Byzantium world, and I ran into a bug that I had forgotten about. So I put out a little update for it to fix the bug, but that mod is out and available, and I think it even was subscribed by somebody. I think ARM subscribed to it already. But it's called Player Only Cabinet Actions. That's the name of the mod for EU5. If anybody out there plays EU5, it's a cheat mod, but it's my kind of cheat mod. It's, you know, it's got my flavor on it, which is kind of disgusting to think about right now. But so we need to actually work on a feature that I built many, many moons ago, and I just kind of have left it sit, and I kind of need to refamiliarize myself with the feature itself. And then we can also look at if there are any bugs that are reported on the mod. We can look at those. I am on a special branch, however. I created a separate branch just for this project to fix the pipe system. So the pipe system, I did some analysis on the pipes mod, because you know I'm making this mod without any experience in any of the other mods that I'm trying to replicate, right? So I don't have voxel modding experience that I can fall back on. So I'm just kind of winging it here, right? I'm taking the experience of programming that I have. I'm taking what little experience that I have in using something like Immersive or using the pipes mod, and what little information that I can glean from descriptions and other things and the code base itself. And I'm sort of building these features with what I think they did. But when it came to the pipe system, I missed the mark. Because, trying to look at an established Minecraft mod that's written in Java, even you can browse the source code. If a mod is very well established or has had years of development, as a C# programmer, as a C class programmer, looking at Java is like trying to translate, cuneiform to English. Like it takes a little bit. Java and C# are similar, but the way that the objects are structured is very different. Like on the top of a C#, you have namespaces here that are included. If I use an object, like let's say you have a vector 3i object, well, that's in their math tools, right? Venturi API math tools, which includes a whole bunch of base math tools. Like it's very obviously named namespace, so it's very helpful looking at that. Well, in Java, you have to include every object that you use in your code, right? So it's not just including a namespace that includes many, many objects. It's including each individual object. So if you can see in here, iCore Client API, iCore Server API, imagine there's an import on the top of this where you have to import every damn custom object that you use in your code. So even looking at your average Java object, the top block is just going to be a list of all the shit you have to import into the thing. And it's like, who in their right mind can keep track of all that stuff? Like, I don't understand why the language has to be built like that. Why the compiler can't figure that shit out for you. Like, hey, he's addressing this object that's in this namespace. How about we just map it, right? Why do you have to import everything at the top of? Oh, anyway, that's just one of my complaints with Java. But getting back to my original point, the actual like looking at the code to try to discern how it works is very difficult because I'm not familiar with their code base. I'm familiar with mine. So looking at their code base, they might have names of objects or structures or whatever that I find that I have a hard time cracking into mentally. So I didn't really fully understand how that mod was put together. And so I built my pipe system with the sort of inner workings of what I thought might be working. But it was still off. So what I need to do, and then I've since, because of so many little bugs have been posted regarding the pipe system, I did a deeper analysis using certain tools to just analyze the code and sort of summarize like how is this overall put together, right? Which the tool was very good at doing that, right? Here's a source code file. How is this put together? So being able to look at it in that way, I was able to sort of narrow down how it works, which was really handy. So one of the things that's different with the pipes mod, because it's coded in a way that it's coded in a way that they've tried to protect performance as much as possible, and that's my whole shtick, right? That's how I've coded the whole mod itself. So that's why I was attracted to that particular feature, because if you have something like Mechanism, right, The mechanism way of doing it would be super damn easy, okay? But it would require every pipe block, right, to tick, right? That's how the mechanism one works. Like, if you think about a mechanism pipe for energy, or any, that's literally for anything. But if you think about it for energy, is the best example. Think about each pipe block being a little battery, right? And so each pipe then is a little battery that has storage in it. Well, when you have a line of them, they're just little batteries that are in a line, and each position can push and pull power however it wants, right? If it has machines next to it, it can push power into the machines, right? If it has another pipe, it can look at another pipe, and if that pipe's energy is lower than it, it'll push a little bit of power into the pipe. And that's how it works. It just ticks. Every one of those instances tick. And so all you need to do is feed in power from one side, right? That pipe gets a huge amount of power in it on its own, which then goes to feed everybody else, right? It's kind of a pressure-like system. You're building the pressure up, you're building the pressure up here, and then down the line, it's just going, oh, we're a little bit here, a little bit here, a little bit here, and it's ticking all of those all the way down the line as it's feeding, the machines as well. So it's like a push-based system. All it does is look at it and say, hey, do you have more power or less power than I do? And if you have less, then I'm going to give you a little bit of mine, right? Whatever that transfer rate is, I'm going to give you some of mine. That system would be easy to implement. Honestly, it would be really easy to implement. But when you have builds that have many, right? Many pipes, now you have hundreds of things that are ticking rather than 5, right? Let's say you have maybe 5 machines in your build, but you've got 50 pipes all running around for things. Well, rather than the 5 machines ticking, now you've got the 5 machines ticking plus the 50 pipes that are all ticking as well. And I wanted to avoid that because I know how people build their factories. I build my factories, right? I've seen the screenshots. I've built my own factories. It gets out of hand sometimes. So the pipes mod is built in a different way, and it's built in a way that only the extraction nodes are ticking. That's all that's ticking is the extraction nodes. And that's how my system works. But I built another layer trying to add a little bit more optimization. I added another layer that was the pipe network. And that's been the bane of my existence. I should never have done that. So we're going to try to use a digital scalpel and excise the pipe network from the system. Okay? Now, I really want to try to do this in a way that doesn't break people's games when they update the mod to whatever version this is, right? Whatever the next public release is, whenever that happens, I want people, even though I'll tell people, break all your pipes. Break all your pipes before you do this, before you add these new ones, right? Do it all, because this is going to be a very different system. You don't want any of the old pipes, but I want to do it in a way that's not going to break people's games. Like I really do. So I'm thinking about just leaving the block entities and stuff for the old pipes, just leaving those alone. That way, when they do go break all of the pipes, the game itself will clean all of that data up for me. And then I don't have to worry about it. Okay. Now there's probably going to be some lingering data with the pipe networks, which will be fine. I'm going to leave there's going to be commands that you're going to be able to run to just to make sure the data is clean and clear. But it's the amount of data saved via pipe network is minuscule compared to like what it takes for all the terrain and stuff. So it's going to be trivial. If there is data wasted, it's going to be 2K or something like that. It's going to be a tiny amount. So what we want to do is let's do a review of the feature and figure out. And I got a good amount of sleep because I stayed up for 2 days. So Monday I really didn't go to bed at all. I was up playing EU5. I played EU. Yeah. I don't know why I'm enjoying that game so much, but it's just so different from what I usually play, and that's what's refreshing about it. Even though it seems that ARM is not having any fun, it's like I just want to tell her, like, if you're not having any fun, don't play the damn game. Like, don't be playing it on my account. What I want to say is, if you trained an AI, like, honest to God, if you trained an AI on how to play that game, right? All the different variables, you could train something like a DeepMind AI on EU5 easy. Right, you just have to have a way of simulating games, and you just have it play 1 million games, right, or 10 million games, or 100 million games, right, and you just train it on how to play the game. You'd never win a game as a player if you're going up against AI that was actual AI, because the latest thing she complained about was that it was it cheated, the AI cheated, and I'm like. Yeah, that's how computer AIs have worked forever. Cat. What? You were sleeping on the bed, and you just come out to yell at me. She comes out and be like, "You're too loud." I was sleeping. I'm already a little hot. It's a little warm in here. I might have to take my sweater off. But yeah, if you trained an AI, an actual AI, like a DeepMind sort of AI, on how to play EU5, the human player would never stand a chance, because the AI would be able to manage so much more in a single tick than a human player, right? And the same is true with they created an AI, a similarly trained AI for StarCraft. I think StarCraft 2. And they actually had to go in and nerf it, right? Because the AI, the StarCraft community, if anybody doesn't know this, your ability to play at the high levels is down to how many commands per second that you can input into the computer, right? Clicks per second, whatever it is. The people who do that the best, the highest, the people who get the highest amount of commands per second are the ones that are on the leaderboards in the world, right? The top 10 players. Well, when you put an AI and you put an AI in that, and you have a computer actually able to do that, the computer can input exponentially more commands per second than a human player can. Okay? And so when they finally trained the AI on how to play the game, the top human players didn't stand a chance. They couldn't even come close. So they had to go in and artificially nerf the AI to cap at a certain number of commands per second. Because it's like anything over this would be impossible for a human to do, therefore it would be unfair for an AI to do, right? So you'd have to do something like that for like EU5. Because imagine an AI in charge of France, a behemoth of a country, and they're able to manage an army. They're able to manage their economy. They're able to manage everything on a scale that a human just can't even come close to. So I just find it amusing that ARM has done nothing but complain about the game since she got it, and I'm just like, don't play it if it's that frustrating. It's like, yes, the AI cheats. Everybody knows this, right? When you invade a country that's barely making money and they've got 50 forts right in their country, that's cheating. Like, there's no way they're affording all those forts. Those forts are really damned expensive, right? And if you go into like France, they have 50 forts. There's no way they're being able to afford all of those. So yeah, they're fucking cheating. This we know. This is known. It's been that way since, I don't know, the very first the very first strategy game, like back in the Command and Conquer days and shit. Like that, those AIs cheated their asses off. They barely were functional. Okay, so getting back to what I was doing here, I know I go off on tangents. It's rant day. This is Wednesdays. It's rant day. But we have things that I want to get done here. I first, since it's been so long since I've touched any of this code, really, I've done any of this stuff, I kind of have to refamiliarize myself with how it works. Honestly, kind of impressed with myself that it works at all. So we have block entities. Where is my block defined? Block pipe base. There it is. Okay. We have the block entities. That's where the magic is. The block pipe base. Okay. So this, I don't like. There are definitely aspects of this that yeah, there are aspects of this feature that I won't have to really mess with at all. But I am going to have to do something here. Mark pipe dirty. So it looks like all of my It looks like all of my pipes already have a block entity. I don't know if see, this is what I'm not sure. The pipes with a Z, the pipes Z mod, if they control what has a entity or not. I don't think if an entity exists, it's bad. An entity can exist in a block position it won't matter. I'm just going to have to ensure that it won't matter. Now I have to figure out like how. One of the things I need to change is how insert nodes, because I want to while I'm doing this, I want to add a feature to the feature. Right? I want to add the ability to color code extraction nodes and insert nodes. So you can say the extraction node is red, right? And then it will only look at red insert nodes. It'll be filtered by color rather than by item. So you can control a little bit more carefully the actual insert nodes that it looks at. Right now, there's no way to do that. It's an extraction node it doesn't concern itself with insert nodes. It's just like whatever the insert nodes are. Where if you add a filter if you add a color to it, an extraction node, it'll say, hey, I only want that color insert. Okay, so we have an on neighbor block change. This is going to be a big one. So we're going to do overhaul this. And then to do overhaul this. So right now, let me just summarize how the feature sort of works now, and then we can talk about what the feature, what I'm moving towards, and for the feature. Right now, when you place a block, when you place a pipe here, or a neighbor block changes here, it's marking the pipe dirty, which is a custom call, mark pipe dirty. And what this does is it basically pulls, if we go to definition here, right, this call does a whole lot of shenanigans, but what its baseline is it grabs the manager. And it's like, hey, what pipe network am I a part of? Right? And like it basically informs the pipe manager of a bunch of changes. Here's the pipe get network, quick network update. It does a bunch of like network changes because there's a bunch of data that's stored in the network, right? All the different positions of all the different pipes is stored in the network. And then it just says, hey, quick update the network, I have a new pipe. And very much I modeled it when I started this feature, I modeled it off my electric network because I was like, hey, if the network works for one feature, why can't it work for another feature? So it grabs the network, it informs the network, right? All the different sidednesses that you see in here, disconnected sides, connected sides, these are all fairly important. But yeah, these are still going to be used like this, but the whole network thing. So when you place a new block, or when a neighbor block changes, it calls this network, and it's like, hey, there's a quick update to the network, and then the network grabs that and is like, oh, now I'm gonna, the network should have access to all of its nodes and update all of its nodes. All the extraction nodes. Well, the problem with that is, what happens if a chunk isn't loaded? For one, right? You have a pipe network that is ungodly long, way too long. That's not meant for super long stretches of pipe. Trust me on that. So if you're editing a network and for some reason there's a chunk that isn't loaded, or some other chunk shenanigans happen. Maybe it's getting saved in that moment and it can't quite access. I don't know. Any number of chunk related issues. Well, if a pipe network is trying to update things and there's let's say there's an extraction node that's in that chunk that's not accessible in that tick. Well, that's not getting updated. Right, you're adding a pipe over here. This extraction node isn't getting updated. The extraction node is not aware of the thing, right? It doesn't know. So how do you solve that? Well, the whole pipe network itself is the fundamental issue. So what I ran into, especially with chunk boundaries, is the mod tried to assume that if a block if a neighbor block changed, you trust that first, and then any of the player overrides were second. Well, that was a problem because if you had pipes that cross a chunk boundary, and the chunks were reloaded in a certain order, right? The pipes would forget or assume they should be connected when they shouldn't be. And so I need to also change the logic around how that is set, because it's very janky right now, and I'm very not happy with it. So we need to add this BE pipe base, right? We need to add a new version of this. Fundamentally, we need to add a new version of this. Again, I want to try to do this that doesn't break the original. So what do we call the new pipe? Do we just do BE new pipe base, or new BE pipe base new? Do we go full out, like embrace the cringe? BE pipe base new. We're going to go here. Control All. Nope, that's the wrong thing. Control All, Control C, Control A, Control V. Got to start somewhere, right? Let's start by just being completely overwhelmed. Okay. So the connection side, a bool array here, is a really simple. It's northeast, southwest, up, down, right? Is the 6 faces of a block, and that's where these connection sides come from. Is northeast, southwest, up, down. And so you have these Boolean things here. And for my time when I built this feature originally, I have a little bit more experience under my belt. I have a little bit more understanding. Every new thing that I implement in this mod, I almost said in the game, every new thing I implement gets me a little bit more experience and a little bit more confidence in how to approach this. And if somebody is out there who wants to learn how to do modding, who doesn't really know where to start, I would say start very simple. Start with very simple ideas, very simple concepts that have a lot of examples of other mods that do similar things, and just look at that code. Get familiar with it, get an understanding of it, of the very simple. Don't start as your first mod saying, "Oh, I want to do applied energistics," right, for Vintage. That's not your first mod. Trust me, don't set your expectations that high if you have no experience. I made 13 mods for Vintage Story alone before I ever tried to tackle vintage engineering. Not to mention the 25 years of modding experience that I put in and coding that led up to that point, right? So you don't start a project with no experience at all and reach for the stars as your first project. Start with something that's manageable and simple, and then build on that knowledge, right? And you may build fast, you may build slow, you may build whatever, right? Whatever your speed is, you just build upon that knowledge, you gain the confidence to tackle certain things, right? And then you just move on from that. A slow and steady process. So, it's a process. It's not a thing that just happens overnight. And I myself am in the same boat. I have learned so much with all these different features and stuff. It's been very helpful of slowly building on that knowledge over time. I didn't, I went into modding Vintage Story originally to learn like the system, and then when I learned how good the back end was, when I saw just how well it was built, I kind of fell in love with what they built in the back end of the API, it's just a joy to go in and tinker, because man, you just so many things that you can affect with simple mods. It's beautiful. And then when I started getting into the code, it was like, wow, this was built. This is like the modding API for this game, or the API in general, and the back end of the code is the gold standard for any game, right? It's absolutely beautiful. And I've modded many games, and Vintage Story is by far one of the easiest and most flexible data-driven systems that I've ever seen, with a modding API that can largely do anything, and easy to get into. As daunting as it may seem, like, this is fairly straightforward stuff, versus something like Hytale that just came out is a wholly different type of architecture. Like, it's very, very different. It's gonna take a lot of work. So yeah, it is what it is. But we obviously have errors in this code because I'm building like GUIs and stuff, and the part of the GUI is asking for, right, the BE pipe base, which this is now a different object. So, this is a thing. So the block pipe base, I have the to-dos. I think I have the to-dos on here yeah. Okay. So, yeah. So I kind of summarized how this works. You place a block, or you place a pipe, you change the neighbor of a pipe, it grabs the network that's associated with either like the pipe itself or its neighbor, and then using the network tries to inform the network, right? Tries to inform everything else. Well, that middleman, the network, the middleman between all of that is the problem. Cat, you should be used to this by now. My talking. She's just, because I talk to her all the time. Yeah, I do. I talk to her all the time. She's the only one around. She assumes that I'm talking to her, right? Which is why she freaks out when I stream. And I've been told I have an ASMR voice, so if I had a Gilbert Gottfried filter for my microphone, I would have tried to use that today. That would have been fucking hysterical. I can't even fake his voice. I just can't. It doesn't do him justice. You have to look at a YouTube video for Gilbert Gottfried if you want to know what I'm talking about. He's an old stand-up comic. Anyway, what was I saying? Oh, yeah. So the middleman of the network, right? That's been the bane of my existence, right? That has been the cause of a lot of problems. Is that there's that network, when you have a situation in your base where that somehow gets corrupted, where a pipe forgets its network, or you have a section of pipe that isn't loaded in the right order, like chunk, and this comes down to chunk loading as well. as the chunks are loaded and the pipes sort of reconnect themselves, they broadcast to a network like, "Hey, I'm back," well, that's a problem when the load order is done in a way where the extraction nodes, you have one extraction node in one chunk and another extraction node in another chunk, and they're loaded in a way, and now the insert nodes don't know what the hell is going on. They don't. So you have a problem where you cannot guarantee the chunks are going to be loaded or the order that they're loaded in. And so how do you handle a network that is fractured like that? That's been the source of the problem, is the you can have a single pipe network associated with several different chunks, right, in any shape, that are loaded in any order, right? That can load in literally any order. So the bigger the pipe network, okay, right now, the way that it's worked, the bigger the pipe network, the more percent chance something is going to go wrong. I'm just putting that out there. If you have a base, if you're playing this game and you have a giant pipe network, there's a higher percent chance that shenanigans will happen right now because of how the chunks, how does the thing handle when a chunk loads in? Like, how does this work? And it's a huge problem. And so because the pipe network itself, it's not guaranteed, like, how does it know what to update and what not to? If it has an awareness of every pipe on its network, but some of those pipes are not yet loaded, how does it then inform the extraction nodes of what is loaded? It is a nightmare. It's a nightmare. Okay. So we are going to excise the network completely. The pipe network system is not needed. So what we're moving towards is more of the pipes mod itself. And how that mod works is when a neighbor block changes or a new pipe is placed that extends an existing network, okay, all it does is essentially marks the pipe dirty, right? So the block entity is marked dirty. While the block entity, when it ticks, it's going to pick that up. It's going to say, "Hey, this has been marked dirty. I need to update all the valid blocks on the network," right? All the valid blocks that are all connected. And I say network here loosely because there's going to be no concept of a network. The pipes that are connected are the pipes that are connected. It doesn't matter. It's just going to spider through, right? So when you place a block, or when a neighbor block changes, that's a valid connection, right? The pipe connection logic saying, "Hey, can I connect to this?" If that is true, and an insert node is valid, then that is going to be it's going to be an event that then marks the pipe dirty. If a pipe is connected, right, that doesn't have any of its own connections, all it does is connect to another pipe. It doesn't need to tell anything, right? It doesn't need to inform all the extraction nodes. So that's a savings. When you're placing pipes that don't connect to anything other than other pipes, the extraction nodes don't care about that. They don't. It's only when you build upon a pipe network that actually has valid connection nodes of machines or chests or tanks or whatever you're connecting to. Only when those nodes exist do you need to inform the extraction nodes, right? Otherwise, you don't need to do anything. And that's a huge savings because on big pipe networks, most of the pipes are not going to connect to anything. All they're doing is extending things. So as you're building pipes that don't connect to anything, the extraction nodes don't give a crap about that. They don't care. They don't need to know. So you don't need to tell anything. You don't need to inform anything or mark anything dirty, which is a huge savings, right, of computation, because you don't need to tell anything. You don't need to spider the network. It's only when you do that next block that connects to something that's like, oh, I connect to something, I need to inform all my extraction nodes, right? Then it will spider through all of the connected blocks, and it'll inform everything. So here's a question. I'm faced with the possibility of one of two ways of managing this. When that happens, when you place a pipe that connects to something, right, a chest or a machine or a tank, whatever you're connecting to, when a connection is valid, and I'm spidering through the network to inform said extraction nodes, any extraction nodes that are on the network, it's not going to know how many. There might be 0 extraction nodes on the network at that moment, but it doesn't know that. So when I'm traversing that network, right, the node graph that I'm looking at, all it's doing is looking for other pipes. That's all it's looking at, as well as making sure it's not bypassing player overridden connections. Right? If you override a connection between two pipes, if you force break that connection, it's going to honor that. It's never going to override that. It's going to just say, this is a broken connection. Do not look at that other phase. So with that, the two ways of doing this is you traverse the network all at once. You keep in mind all of the insert nodes and all of the extract nodes, right? You keep those block positions in your pocket, and you spider through the whole network. And then after you're all done, after you're out of pipes to look at, you update all of them all at once, and you pass to each extraction node, you pass a list of all of the insert nodes. And then you mark the extraction node dirty, so the next tick, the extraction node says, hey, I'm dirty. Oh, I'm such a dirty extraction node. Then it updates, right? It updates its insert nodes based on its position and the distance, because it sorts everything by distance. So it already got a list of all the insert nodes, right? And then it says, okay, I'm dirty. Take all the insert nodes, sort them by distance, and then save that, for myself. That's, for me, that would have been, I think that's going to be the way that I do it, at least to try it. The way that the pipes network does it is every extract node also then, like, all the first, so the pipes network, when you place a block or when a neighbor block changes, that causes it to traverse the list, traverse the nodes, and find all the extraction nodes. Any extraction node it finds, it marks it dirty, right? Same process. But it's not keeping track of all the insert nodes. All it's doing is finding the extraction nodes and marking them dirty. Then, in the next tick, the extraction node says, hey, I'm dirty. Then it, too, traverses the network, finding all of the insert nodes, and then saving that list to itself. So if you have 5 extraction nodes on a pipe network, let's say you have a bunch of machines in a row, and they all have extraction nodes on them. When a block changes in that network, right, all 5 of those machines are all those extraction nodes are all going to then retraverse the list. So rather than do it once and just pass a list of insert node positions to each extraction node. So here are the insert nodes. They don't even have to be in order. They just have to be insert nodes. Here's a block position with an insert node, and just here's a list of all the insert nodes. And then the extraction node would just take that list, honor it, and say, oh, this is the list. Like, this is what I've got to deal with. Let's calculate the distance and then sort the list, and then That's it for that would be that tick, right? The tick would be the sorting of its own thing. Then the next tick would actually use the data to insert something into the list, or insert something into the next insert node. But that process then, if you did it the pipes way, each one of those extraction nodes would then traverse the same system. And I thought, when I was looking at the analysis of how the pipes network worked, that was the first thing I narrowed in on, was an efficiency that you could eke out where that traversal could be complete right before the extraction nodes are updated, because it's all going to happen very, very fast. You're going to bounce around and traverse the whole network, right, while maintaining a little list internally of all of the extraction node positions and all of the insert node positions. And then you'll be able to go through and say, here's all the, like, after you're done with that list and you're out of blocks, you're out of pipes to look at, now you know the finite list of here's all the positions, here's all the insert nodes. Then you update everything all at once. You just iterate through all the extraction nodes and you say, here's the list of all the insert nodes. And it's the same list. And then each extraction node would have its own copy sorted by distance. So it's a little, what we're changing to is kind of is a little slightly less memory efficient, very, very slightly less memory efficient, but in many ways more memory efficient, because we're not having to maintain a network object in memory somewhere that is being manipulated by every time you place a block or whatever. It's just like, that's, we're removing that. So so if we want to redo this, do we want to do block pipe base? Do we want a new version of this too? I'm pondering. I might need a new version of this, because we're going to overhaul this and this. Yeah, we are definitely, I think we're going to need a new, so we're going to do Control A, Control C, add class, block pipe base new. Okay. And we're not going to finish this overhaul today, but I just wanted to cover like what was changing and why. So I wonder how, when you break a block, Windows for some reason completely just forgot about my background, the nice cathedral background that I had. I don't know why. Like, I just logged into my machine one day and the background image was gone, and I was like, oh, you just completely forgot about my background image, I guess. Stupid OneDrive. I'm going to prevent myself from ranting about OneDrive, but I want to excise OneDrive from this machine so bad. Oh my, I am so tired of OneDrive. I am so tired of it. Anyway, We want to search for on block broken. On block broken base block. Okay. What I'm looking for when you break a block, when it looks for what entity is there, because it obviously when you break a block, it needs to clean the entity up as well. What I want to know is how does it know what entity to clear? If is it just like, hey, delete the entity or whatever at this position? Doesn't matter. Doesn't matter what entity it is. Just clear it out. Like we don't need it. Or if it looks at the entity definition, if it goes and says, oh, what is the entity at this position, and then get rid of that, or does it just like scramble it? That's what I want to know. Okay, on block broken. This method needs to remove the block. No kidding. Entity class. Right here. Entity.on. Oh, it calls the entity on block broken. Yeah. Because if I went into the existing pipes and I changed the entity to the new entity, right? And you go into your existing world with the old pipes and you break them. Well, those pipes, right, are going to have the new entity. So it's going to come in here and say, hey, is this entity class? Well, it's going to be the new entity. And so it's going to call the new entity on block broken. Well, the new entity is not the old entity. So it's going to call it, but so I think I'm gonna have to define a brand new set of actual pipes and depreciate the ones that are there, and eventually they'll be deleted, right? Eventually they're gonna go away, which is why I hate that I have to use new, because they're gonna be new for the rest of time, right? There's gonna be block pipe based new 20 years from now. So yeah, I'm gonna have to. Oh, by the way, this kind of tool, I have not been able to find this kind of tool for Java at all. Because Java is not compiled into a single file, right? You have a it's not like they don't have DLL files, right? When you compile a Java file, it goes into each individual file, right? So imagine this project, every one of these files would be a separate compiled file. That's crazy. This is why it's so hard looking at Java and how Java objects are built, because every individual source file compiles into its own compiled file, and it's just it's hard to get the big picture when you can't use a tool like this to sort of navigate an object and figure out all the little bits and pieces. This dnSpy has been a lifesaver when it comes to VS modding. It's just so good to be able to just bounce around and be like, what is this, and what is this, and what is this? It's infinitely, it's incalculable how helpful this is to be able to do, right? Where you can search things. Anyway, I'm done. I can't rant about Java anymore. Okay, so we have a bunch of stuff. Where's our starting place? We need to close the old. I don't want to accidentally do anything with the old. So how do we want to do this? first we want. So initialize is called. So when you place a block, if you place a pipe, it instantiates a new pipe, places the object in the world, and it calls initialize. But when you load it in a chunk, when it's already placed and you load the chunk, it calls from tree attributes from, it loads the object from disk, calls from tree attributes, then calls initialize. The order of operations there is very, very important. So this line here, question mark equals, what this does is the question mark is a null check. So essentially what this does is it's a shorthand way. Connection sides is saying if connection sides is null, right? Question mark equals. If it's null, then set it to a new bool. But only if it's null. If it's not null, don't execute this line, right? Don't question mark is like, if it's not null, don't do this. Only do this if it's null. It's a very, very handy way, right, of doing this. Oh, my nose. So what I want to do with the feature that I want to add is I want to also add insert node, right? So we grab the extraction nodes here, the pipe extraction node, which is where? There it is. It's a block entity container, right? And I did that because it has an inventory. That's why I did that. But I'm not sure if that's the best way to do it. The insert nodes. What other possible information, data, storage, otherwise, would we possibly need for an insert node? Because I mentioned the feature of color coding the insert nodes. And we can work out rendering in a later. Pipe extraction node. I don't think there's a color. I don't think there are standard colors. I mean, there are color utils. These are more for render. Ooh, that is a lot of things. You know how Minecraft has 16 colors, right? And there's just the standard order of colors. I don't think VS has anything like that because it's not bound to those colors, right? It's not. You can basically set whatever colors, but I don't know. What are your thoughts, Oz? You're here. And Renegades might be around here, but there's two camps around this filtering thing that I can think about, right? Insert node filters. Now, the Laser.io side and sort of the Minecraft mentality is just color code it, right? You have like a finite number of colors that are like, you have 16 colors minus one, because one color would have to be no filter. So like white would be like no filter, whatever goes whatever. But so like 15 colors, you'd be able to set the extraction node and the insert nodes and filter it that way. That's like the Minecraft mentality. Second to that would be the factorial mentality, where the filter could be literally anything, right? It could be a block. Like all it would be like, hey, what filter do you want this to be? And you just be able to drag and drop something into the thing, and that would set the filter, because it would be a code, right? I would just grab the code of like, soil medium fertility or whatever that code is. That would be basically become what the filter is. So that the reason why that's a factorial mentality is factorial is anything. Like anything can be a signal. And so, one way is really easily, you just click a thing and you click the color and the day is done. And the other one is you have to really make sure it's the exact object, but it allows you hundreds and hundreds and hundreds of ways of filtering, right? You, instead of being bound by 15 different options, which is still a lot. I mean, if you have a single pipe network, that you need more than 15 like different filters, like you might have to reevaluate your pipe network, because that is a lot of different filters. It's a lot of different places to be putting stuff that you don't want anywhere. Like you might want to rethink your pipe network at that point. So like the other one is a finite number, but very easily sort of managed. And the other one is, not infinite, but much broader, much more flexible, and could eventually possibly bind into a signal system down the road if I ever get to that, if nobody else ever tackles it, or if it's commissioned. If anybody wants to commission the signal part of the mod, I did leave that open. So anyway,
man, that is rough. A rough question. I honestly see merit in both of them.
I know that's why it's a good question, because I could possibly code it in a way that is sort of both, because the color could be a code in and of itself. I could encode it as that, because the drop down selection, right? If you just do an option and you pick red, right? Even though the game really doesn't have a code for red, I could save it as a code and just be like, there's the code, right? This is red. It is code -red or something like that, and just save it as that code. And then way down the line, again, if it's commissioned, I want to put that hint out there, put the signal system, and you just bind into that system. And you're just like, hey, instead of this color, you're just binding into the code as a code, basically. So that's kind of it's not the best of both worlds, but it certainly is more flexible in terms of like, hey, I want to leave the option open. So I would have to then define sort of an enum, right? You have an enum of like selectable colors, and I could define the colors in JSON, maybe in a config. Just here's all the colors, and here's like the RGB values of all the colors, right? You just have a thing that's like the option of the color, and then you have the RGB values. So if somebody's like colorblind or something, you could be like, you just change those up via a patch. That's and I try to expose as much as possible of the mod into some data-driven architecture, because that's kind of the flavor of the game. Like, everything is sort of data-driven. So when it comes to an extraction node, what data that I would need to add to this would be a color code in some way, or a filter code, or because you can already, the pipe filter object can already filter what object is looking at extracting. So the pipe filter is probably one of the most complex things that I built for this mod. It's one of the little, it's something that's it's so ubiquitous. When somebody uses the pipe filter, right, and you're going into the pipe filter and if you're adding different things and you're going through that, to get that working is one of the most complex problems in the mod. Like, it's incredible how complex that process is. The GUI, everything about it is really complex. So it's not filtering the actual object, it's filtering based on like color, or like what would be a generalized name for that. You're not filtering the item you're looking for. You're
class of item, category.
But it's limiting the extraction node to the an extraction node set to whatever this value is, whether it's a color, whatever it is only going to look at the insert nodes that match, right? So it's like on a single network, you have extraction nodes that can be generalized, right? An extraction node that doesn't have anything set will look at any insert node that also doesn't have anything set, right? So no filter is kind of its own filter in a way, because a no filter extraction node will not look at a red insert node, right? Only a red extract node will look at red insert nodes. So it's almost like a subdivision. It's almost like a subnet. I've been trying to avoid using the term network as much as possible, because I'm literally excising the network from it. So like subnet would be the best. Subnet because it would be basically it's gonna be basically a string, but it's your subdivision, maybe
port. We're
getting into computer tech now. I think I'll just go with subnet for now. So we're gonna do protected string subnet equals string.empty. Public strings subnet. Subnet. A special tag on this no extraction that filters that only pushes a special tag for this extraction node that only pushes items, that only pushes to insert nodes of the same subnet. Okay, then go down here. Come on, subnet. So now this saves the subnet, right? And then when it loads string.empty if it doesn't exist, which that means we can use the same extraction node object with the new version, because when you're loading an old extraction node, it's going to try to grab that. It's not going to exist, so it's just going to be string.empty, which isn't filtered anyway, which is fine because that is what it is. But now the insert nodes, we need the pipe base to be and I think I've changed my variable naming scheme like 3 times as I've worked on this mod. So there's much work that could be done just normalizing all of my variables, right? So I tend to now, when I declare variables for my objects, like my built-in member variables for an object, I tend to use underscores to start, because it's so much easier to filter when you have underscores on all of your like important variables that are not part of the base object, which is why, my subnet object here, right, starts with a underscore, because it's so much easier to just have an underscore here that, okay, so pipe base new, this is a block entity, so we have all the different push connections, which is a pipe connection. Okay, so this pipe connection here, I forgot that I have a push connection. Okay, so pipe connection then. We have position and facing private string subnet. Why do I have a squiggly? Why do I have this? Oh. Subnet. Actually, I can simplify this to subnet. A then it only receives items from extraction nodes of the same subnet. Okay. Why? Must be a compile time constant. What? String.empty is not a compile time constant? It's read only. No, I'm not going to fix with Copilot. Jesus. Huh. I didn't know string.empty was not a compile time constant. Interesting. Well, that's not going to work. Yeah, 18 references, by the way. Lot of things. Lot of things in here. We're going to need to make sure this is... good to go. Pipe connection. Int distance. Yeah, because we're adding a new proto member onto this, this might cause problems with people's existing stuff because the proto stuff, this is from the proto buff. This is just, it's a library that can pack, it packs data into binary formats, right? Whatever that data is, as long as it's defined, as long as there is a 2 bytes object, right? As long as there is a 2 bytes and from bytes, you can actually pack data into a little bit better formats, mainly for, transmission and storage, of course. So if we so what we're doing here, we're doing 2 tree bytes and from tree attributes. So when we load, I'm just think about this. When we load this off of disk, and somebody is in an existing world, and they try to load one of these pipe connections, it's going to grab the bytes, but the proto buff here because the pattern has changed, right? This, I don't know how I don't know how Protobuf deals with loading an object off a disk that used to have 3 members, now has 4. I don't know enough about how this Protobuf works. We might have to roll a new one of these as well, which I was trying to avoid completely changing everything. Because I don't know what gets called if it's saving. How am I saving on block entities where this is going? How am I saving this data? Yeah. So when I save this, the serializer util, right? This is essentially what's calling that 2 bytes. So serializing util is saying, hey, take that list, the insert sides, right? Take that list of pipe connections and serialize it into a block of bytes and save it as a tree, but it's a tree that's just bytes, right? It's sort of taking the bytes and turning them into text, something like that. But set bytes is just setting a basically an array of bytes, and then when it loads, it's just deserializing those bytes into an object. This is what would crash right here when you if you loaded what we just did here, right? Because it's calling this from bytes. It's looking at the object. The serializer util would probably look at the insert node, right? Or the pipe connection, sorry. It would look at the pipe connection, figure out, oh, you have these proto things, right? You have 4 proto things. So this is the pattern I'm expecting to load in, but it's not going to be that pattern. That's the problem. I don't know if there is a proto thingy-madoogle, proto partial member. I don't know what any of these does. I don't know what partial member is. Maybe Oz can look that up. Let's see. Let's do proto buff partial member. What is it called? Proto partial member. Partial member attribute. Oh Lord, that is proto buff serialization. Okay, so this is just it's for like partial classes, it looks like. Yeah, so that's not. Is there a proto member? Is there a version of this? Protobuf optional proto member. I don't know how to. I don't know if there's a way to do this. To be like, hey, if this is part of the object, then load it. If it's not part of the object, please don't crash. So, right. So we have this proto member here, but I don't know if this is. I don't know if there's like an optional. Yeah. See, this is system.runtime. This is not protobuf. Um. Proto. Yeah. If anything, it would probably be under the proto contract. Um. Optional member. Um. A proto. Yeah, even within like the C sharp like ecosystem, there is still so much to know. Like as much as I've coded in C sharp, and as much as I've been in this ecosystem for as long as I have, I still am only aware of a small amount of actual features of the language. It's amazing how much stuff there is to know nowadays. Which is why something like AI is actually extremely helpful. Now I don't use it to directly code. Like I don't have any code that's in the mod that's from AI, but it's a great tool for learning like how to approach something maybe from a different angle, because it's able to see much more, and it's able to ingest a lot more data and information than I ever could even come close to. He's gonna make some food. We'll be a while. Ooh, he's gonna make some food. Public int b proto member. Oh, let's see. Proto gen. Another option to use default values. Ooh, that I like. What? This is great. Like, so like another option is default values. Should serialize. No, I don't want to do that. the only object. Um, null wrapped value. Optional. Hmm. So like, how is a static read-only file not a constant? An argument must be a constant expression. Oh, I did that wrong. Like, what is string.empty? I'm just curious. This should be string. Thank you. I was like, I know it's in here somewhere. I should be able to see it. String. Woo. Dot empty. Intrinsic. I have no idea. Like, I have no idea what some of this. Like, what is this? Intrinsic. What is that? I don't even know what that's for. Attribute usage, class struct, blah blah blah. Intrinsic. I don't even know what that does. Like what is it? Like what is the assignment of string.empty? Like what is the, it says what is it though? Okay. Let's back out of here. Yeah, I don't know. I don't know what this would do. Specifies the default value for a property. I don't know if that fixes it. Doesn't look like it would. Some of these. That Stack Overflow that I was looking at, by the way, this is why this is so funny. The protobuf 14 years ago. That's how old that fucking answer was. Oh, 14 years, 9 months ago. That is crazy. How old that question and answer was. I don't even know what version or protobuf Vintage Story uses. This is why it takes so long to get anything done. Is I get stuck on something like this, and it's like, yeah, I could roll a new pipe connection. Yeah, I think I'm gonna have to. I think when it comes down to it, we're just gonna have to do that. And we're gonna need a new pipe connection. Should I put these in API this time? It's not really an API call. It is an object. So add class pipe insert node. Add. I'm going to do that. Paste. Clear. Okay, we have the position, face connection. Basically, what face is it on? Again, that'll be facing.code, which is northeast, southwest, up, down. Those are the different codes. Block facing. Yeah, facing.code. Okay. So I'm encoding it in a block facing object. Good. Distance and subnet. Why is this say make field read only? It should not be. Anyway, we might need more. Yeah, we need more access here than just this. So get is subnet. Set subnet equals value. We actually have to set. We have to have a setter for this. Because how are you going to set it? You're going to open a UI and you're going to set it. I need a way to set it, right? So, pipe connection. Then I need to do that. This position. What? We have okay. Okay. I think this is making a copy, so we need to make sure we copy the subnet. Even if it's empty, we need to copy it. And then we need to go to, oh, we have this. There we go. All right, now we have a new object to play with. Let's go back to BE pipe base, right? So this is now push connections. This is a new object. It's the same as the old object, but a little enhanced. But we're not going to override the old version to scramble memory. So I am trying to protect things and stuff. So extraction node, we're adding a feature to the extraction node. But if it doesn't exist in the tree already, it shouldn't hurt anything. We're not encoding. Well, we are encoding the extraction nodes from bytes. Okay, let's. There's no where are the bytes? Oh, okay. From tree attributes. To save space, I take the tree and I basically take the tree and I encode it into a byte array, which should
automatically bind. If I can go to the right damn file. Right. So even if this is missing, it should be fine because it's a JSON tree. So the get string, right, when it loads it from disk, it's not going to be aware of what it should or shouldn't have. It's going to load it as a JSON string, right? Just basically like a key value pair. That's all JSON is just key value pairs. So it's just going to load that data however it loads it. It's not going to be aware of what it needs to have. So it's going to load in here, and this get string is going to be like, hey, the string doesn't exist. This is the default. Encode that into the default. So it should load fine. I say should, but it should load fine. Without any errors. The insert node was more of the problem because it was directly encoding that object via protobuf, right? The extraction node does not have a proto contract. There's no direct attempt to encode the extraction node as a serializable item. I use the to and from tree attributes to encode into a tree attribute the data, and then I serialize that. So it's like a slightly different way of doing it, but the listener ID, like I want to make sure that we're not encoding any sort of like network ID. Subnet is what the feature that we talked about. That is not the basic listener ID here. So the extraction node doesn't really care. We have to make sure that the pipes themselves don't have any sort of network ID. So we're taking that out. I accidentally hit a key. I meant to do that. I hit Control Delete and it deleted the line and it scared me. There's about a million hotkeys for this that I don't know. I just never learned. So we have pipe insert nodes now. Like removing that network ID. Well, it's one of the things I like when I'm refactoring code like this is take out the variable that you're taking out, right? Take that out and then look at the red on the side of the screen there. Like all of this red is like, well, now I know. Now I know where all of the network ID stuff is because I got rid of that variable. It was like, what variable? Like, yeah, it's really easy to see where I need to refactor. Pipe insert node, push connections. That might be fine. I might want to change this variable name. Let's do insert nodes. Insert nodes. Insert nodes. Now I have even more red. Now the file is like, what are you doing? So num extraction, num insertion, those are fine. Num push cons debug, those are debug values. I won't mess with those. And then all the connection sides. The disconnected sides, these are the human player overridden sides here. All of those should be fine. Insert sides. List insert nodes. Why is that a list and not... Why did I set this different. I don't remember why this is a list and this is an array. I honestly don't know why are those different. Um um now base, okay. Pipe or num extraction connections. Network ID. Completely remove network ID. Connection sides, extraction sides, disconnected sides, insertion sides. We still need all of these. I don't know if this is not needed or not, because we have this insert nodes and this insert sides. Yeah. I'm going to leave it for now. I don't like it, but I'm going to leave it for now. And then we're going to grab this. Insert nodes. I'm just like, I don't like that each pipe initializes with 6 different insert nodes, 6 different extract nodes. I don't like it. I don't like how that works, because that's when you have a bunch of pipes, right, that don't connect to anything. You still have that data in the background. I don't like it. If we look at an extraction node, we have face code in here. we're already encoding which face the node is in. And I believe we're doing that as well with the insert nodes. Yeah. So the object itself includes the face that it's connected to. So I don't like this. I think we can save some gubbins here. If instead of me doing this for both of these, because these are just bool arrays, these are fine. It's literally a single byte. It's just 6 bytes. That's all these are. Right? Bools. I think bools are technically saved as an int because int is like the minimum addressable memory space that you can have. So it's still 4 bytes. Imagine 4 bytes getting saved, and you're only saving the very last bit. The very last bit is the only important thing. Like I could save all sides. I could save as 1 byte and then bit flag it. There are myriad of ways that you can optimize this, right? I could save all of these 4 different byte arrays. I could save as 1 int. Right? Because you have 6 faces times 4. That's 24. I only need 24 bits for that. An int is 4 bytes at 8. That's 32 bits. I could save as one int all of these sides. Right? All of this data I could save as 1 int and just bit flag everything. But that makes my brain hurt, so I don't do that. Because remember, you could have the first 6, like the first 8 bits, second 8 bits, third 8 bits, fourth 8 bits, and you could just bit flag and an or everything. It's definitely an optimization that you could have memory wise. Okay, so we have. I want to set this back to a list. Oh, look at all that red. Oh, it's basically like my built-in to-do list. All of those red calls. Oh, awesome, Renegade. Pipe insertion node. Where are my pipe extraction node? Where's my publicly addressable pipe extraction nodes? Block entity pipe base. So the other thing we need for extraction node, we need to look at what objects do we have in here. Again, I'm trying to familiarize myself with all of this. That's space tweaks. Ah, yeah. SE, you're jumping headfirst into the lava, man. SE is it's a tough mod to get it, like, to it's a huge mod. Like, it's huge. In many ways, it's bigger in scope than the base game of Factorio. So yeah, SE is trying to find where to mod things can be a challenge for SE, because it's like it's a huge project. The space tweaks, at least it helps that you have something to look at to say, okay, what change is this making, and at least give a hint as to what to look for. But yeah, and of course, with the new version, they could have massively changed how they approached everything, is because of how 2.0 does things and stuff. But okay, what was I looking for? I can't remember. Insert nodes, extract nodes. Oh yeah, I was looking at, does this hold a list of insert nodes? I don't think it does. Listener ID. Oh, I know what that is. Listener ID is the game tick listener. It's not a network ID. So we are going to need, each extract node is going to then have its own copy of insert nodes. Do we want to? Let's not do that just yet. And then we need
A question in chat.
okay, so the access things, just let me, I have to finish my train of thought here. So the what you see here, protected, there's private, protected, public, and you also can find one called internal. They are the, I forgot the term they use. The domain, the scope. What scope is the variable? So public. Let's say you're making your own mod, and you use Vintage Engineering as a dependency, right? You're making an add-on mod, so you include the DLL file, right? As part of your project, you include a reference to this mod's DLL file. You don't include a copy of it. Just like this project, links to the base game's DLL files, right? All of these, like VintageStory.api, these are linking to the base game's API DLL files, right? So with these, what variables, what classes and variables do I have access to when I declare something from one of these other classes? Okay, what do I have access to either declare, or like what variables can I play with? That's where these scope things come into play, right? You can have a public class which everybody can access, right? Public is there is no restrictions. Anybody can declare a version of that object, right? Same with variables that are in a class, right? I can declare publicly in a different DLL file, you can declare a pipe extraction node. Let's say you have your own mod, right, that builds upon pipe extraction node, right? You're augmenting it, you're extending it in some way, where you can build an object based on pipe extraction node that maybe maybe it adds its own flavor. Well, even though you're derived from my object, you're not going to be able to manipulate this variable because it's protected. Protected is, hey, yes, somebody else can derive their class based on this class. Like this is the fundamental part of inheritance, but you can't directly manipulate a protected variable, right? So private, yeah, there's so many different levels to this. Public is everybody can access it. Protected is anybody who inherits, right? So you can create a class that inherits from the class. Protected, you have access to protected members, right? Private, because you can also do private, right? Private is only this object can access it. Nobody outside of this object can access it. So you could not, if you inherit from this, you still can't access private members. And then there's another one called internal. Okay. Internal is only in this DLL file, right? Only in this library. And that's like if you're creating like an API, stuff like that you need access in the scope of your DLL file, that's where you use internal. Very specific use case. Most everything you're gonna use is gonna be either public, protected, or private. And there's another one called abstract. Abstract is if you're creating a object that is only ever going to be a base class for something, right? Then you make it an abstract because you can't really declare a variable of that type directly, right? An abstract, you can't just create. If I made this abstract, it has to, in order to create one, you have to derive it in another class. So it's just like it gives you very finite control, very tight control over who and what can access that object. I actually have a few abstract classes in my mod because there are some things that are like, this is a base class and only a base class. So therefore it has to be an abstract. But yeah, that's where those come from, is just what can access. So protected, if you derive a class based on this pipe extraction node, if you created your own version, you're augmenting, you're adding on to my work, you still have access to these variables, right? Protected means, hey, I am derived, right, from this object. Therefore, I have access to your protected members. But if I labeled any of these private, then you wouldn't. You wouldn't be able to change those. Not easily, anyway. Most everything that I do in this mod is public or protected. Very little of it is privatized because it's meant to be an API. It's meant to be augmented by other people. So, or derived from, or extended, or whatever. So I don't really lock very much down. There is some stuff in like the base game's API here. If we look at block entity is like the base block. The block entity class itself is a base API object, right? If we look at any block entity and we look at the chain, block entity openable container, block entity container. Now you can see abstracts, right? Block entity. These are all abstract. You're not going to be able to declare directly a block entity because it's abstract. But if we look at what's derived from block entity, derived types, all of the block entities, right? These are all derived from block entity. So BE lantern, block entity bed, right? If we look at this is a block entity. But because it's a base, you can compare objects to block entity, right? You can say, hey, is this a block entity? And because C# has any object down the tree, doesn't matter how many levels down the tree you go, every object can be compared to any other in its hierarchy. So I can take something that's 5 rungs down the ladder of inheritance and still compare it to the base, and it will be true. Like, it is still the base. The base of the base of the base of the base, it's still that. So you can compare objects to any item in that chain to make sure that it's right, even to the point of comparing to interfaces that might be used in that chain. So C# is just such an elegant language, and the way that you can use it and stuff. So these iBlock entity containers, so this is a base Vintage Story API object that defines certain behaviors. So I can compare an object not to a class, I can actually compare it to an interface. And if an object includes that interface in any hierarchical chain of command, if that interface exists, it will pass and give me all of the relevant data for that interface. So I can call functions and stuff. This is how the fundamental interface for my power network works. Is it looks for that interface, and that interface could be a part of a block entity. That interface could be a part of a behavior. Doesn't matter what it is. That interface is what's important. Any object that uses that interface is what I'm looking for. Doesn't matter what it is. I, for my machines, happen to use a block behavior, right? A block entity behavior to implement that interface, but you don't have to use that, right? You can include it into your block entity, that interface, and it will still be able to communicate as long as you add all of the proper, like all the things that interface defines. You have to include if you have an object that is that interface. You have to include it. So this block entity container defines a certain pattern, right? That you have to include in an object if you have that. So if we can look right at block entity container, and this thing is just like what defines this pattern? Block entity iBlock entity container, right? You have to define this inventory, a class name, drop contents, and check inventory cleared min tick. This, by the way, that is what broke so many mods for 1.21.6 back in December. This right here. Somebody at the company thought it was wise to change this interface mid-release. They just added this call to the interface. Right? So any mod that defined its own object deriving from this interface broke. Because the pattern of the interface changed between 1.21.5 and 1.21.6, the pattern of the interface changed, right? So a mod that wasn't updated right away was missing that puzzle piece, right? Imagine this is a puzzle. If you include this interface, you need to include all of these puzzle pieces. That's what the compiler and everything is expecting. If you don't, then it's bad. It is very bad, which is what broke everything. Is adding this in the middle of a release. It should never have been done. And it wasn't even. It didn't. They like. I reached out to Tyrone right away, and I was like, I don't know what happened behind the scenes, because he'd never done this before in any of his previous releases. So I know it wasn't him. Whoever was behind the scenes just nonchalantly added and changed the interface, right, between 1.21.5 and 1.21.6. They just added this to the interface. Well, that is a fundamental API. Like, imagine how many things. Everything that has a container and a block entity uses this interface, right? Any mod that also uses it. So it's like that fundamentally changed the API. And so any mod that was being loaded into memory that was using this interface, the behind the scenes, the .NET thing was like, okay, well, here's the pattern. We're loading this object. Well, we're missing this. We're missing something from the pattern, right? And so it caused a cascade of errors and like just like very bad, because you're not even supposed to be able to compile a DLL without addressing all of the interface things, right? So check inventory cleared mid tick. I had to add to this, right? In order for it to compile. This is what fixed for 1.21.6. I had to go in and add this to any object that used it. Right? Usually when they do API changes, it's usually in the base. So 1.22 has a bunch of API changes. Right? So I'm going to have to go through and do this whole process again. But 1.22.1.2.3, they don't do big API changes. Or they're not supposed to. Like, you're not supposed to do those changes. You're supposed to fix bugs, and you're supposed to do that. But the overall pattern doesn't change. So somebody didn't get that memo in 1.21 and changed an API, and that's what broke everything. Is this needed to be added? It doesn't do anything, right? It was a fix for some bizarre. It basically was a fix that somebody put in. If you put food down on the ground, right, ground storable, if you put food on the ground, that spoils. That's what the fix was for. If you put something on the ground that spoils and it changes state, it changes into rot, that's all that does. Mid-tick. That's all that does. It was the stupidest. It was so stupid to change that interface. But yeah. Hopefully whoever got that memo, I hope Tyrone was like, don't ever do that again, because that was disastrous to do that. Plus, it was right before Christmas. It was like, we're going to throw this change out on this interface right before Christmas. It's like, yeah, that's going to literally break every mod that uses that interface. It was crazy. Like, what are you doing? It was absolutely crazy. Okay, so we have a bug here. We have, oh no, it's not a bug. It's just, so we go back to this. We have all of the reds. We have so many of the red. What I want to do here, we are going to just comment out this and this. Okay. So we want to do if I'm going to do this, I might as well go full bore. Really get some red. Just all, like, I want just a solid line of red down here, damn it. Okay, so we do if extraction nodes is not equal null. And then we want this and that. Okay, and then we need to address this a little bit better. For int f equals 0 to f is less than extraction nodes.count. And it's a list, but you can still address it via a index like this. We want to initialize the extraction node. Extraction node initialize convert, yeah. Base index of f. Ooh. Okay, yeah, we're gonna need, this wants a string. Extraction nodes of f dot face code. Because we're saving the face code. We should be saving the face code. Yeah, we're saving the face code. So redoing the face code over and over doesn't make any sense. We're literally saving it as part of the extraction node. We don't need to deal with that. Okay. Mark pipe dirty. Didn't we? We have shape dirty. I need to differentiate the dirtiness. It's so dirty. So we have shape dirty. We have shape dirty. We're going to need well, let's go extraction node here. This is where we added a dirty thing. I'm pretty sure, yeah. We're going to do mark node dirty. Because this, when it initializes, what we want to do when we initialize, because we're initializing the extraction node, right? So we're coming in here and we're actually calling this. Directly. I don't really think we need face. We're already pulling the face code, but I'll leave that as is. I don't want to mess with that. Generating mod. So this grabs the config option. If you go into the config and you turn off network ticks, we want to keep that. Yeah, we want to keep that. So do we want to mark it dirty right away? What actually triggers apply upgrade, maybe? Yeah. Okay. Because we're calling apply upgrade up here. Okay. Even when you don't have an upgrade in it, you still apply upgrade because it actually creates the tick listeners. Because each upgrade, right, the different upgrades are different speeds. From everything from like 1 tick a second to 10 ticks a second, right? So it's a variable amount of tick rate. So if there's no upgrade, then it's one a second. So we mark it dirty. BE pipe base. Okay. I'm wondering if I should, on initialize here, yeah, what I think I'm going to do is mark node dirty like that. Yes, it marks the block entity dirty. That resyncs all my data with the client, essentially. But the mark node dirty, this is what's going to Well, I'll get back to that. Let's go through here. We have a few more. We have a little bit more red to deal with here. So if extraction nodes is not equal to null, extraction nodes are count, initialize. We don't really need to initialize the insert nodes. They should be initialized where there's really not any data to initialize. We don't have tick listeners. They don't really do anything like that. BE pipe base new. This I might need to rethink. Mark the pipe dirty and rebuild the shape. Yeah, the rebuild push connections. This is where the network comes in. Num extraction connection is greater than 0, which we should be pulling from disk. We go to from tree attributes. Extraction nodes, num extraction connections, num insert. I really should base these on the actual number of nodes that we have. Again, the first attempt at this was I just needed to get them working, right? I needed to get the feature working. Now that I have something that works, I can go in and tune it a little bit. It's like the difference between building a car from scratch, right? Every component, engine and all, building it from scratch, or going to a car that's already built and tweaking it. Like that's the difference here. It's much harder just inventing a car from scratch from nothing than it is to go into something that actually exists and tweak it a bit. So the magic here, the thing that's we need to figure this out is we're removing the network. We're removing any semblance of a network from this. The pipe itself doesn't care what it's a part of. It really doesn't. All it cares about what it's connected to. So when this thing is initialized, this is called in two instances. When you first place the block, right? When you first place it, and when you load it from disk, right? Newly loaded chunk. So when it loads up from disk, this is called. And those two instances, what happens or what has to happen? Because when you first place it in the world, it's not going to have an extraction connection. It doesn't default to an extraction connection at all. Right? So it really doesn't. B pipe base. You build push connections. Yeah. So this would never call when you first place it. It would only ever be called when it loads from disk. So when it does load from disk, we definitely want to rebuild the pipe connections. But we want to do it in a way that doesn't use a network. Right? So we need to overhaul that call. So let's go to definition. So the pipe network here, we don't need. because there's going to be no pipe network. Rebuild push connections. This is going to be a little bit more complex. And now if the individual is still here that was wondering, virtual, right? You have public, but virtual is another little modifier, right? Virtual means if somebody derives a class from this class, right? The inheritance level. If you derive your own block entity pipe object and you base it on this class, you inherit from this class, virtual allows you to override the base call and create your own call, right? The override. So virtual means another class based on this can do override void rebuild push connections, and you can override the call, and that way a function somewhere that calls rebuild push connections, it's looking for the highest level of that, right? It's saying, hey, what level is this declared or overridden? And it'll call the highest level by default. And then you, as in your call, you can call base dot whatever, and then base dot rebuild push connections, and it will call this function, right? But yeah, anyway, so rebuild push connections really is, this is where the node graph based search is done. So we have iAccessor world. What I could try to do is create this as a static, which is yet another modifier, a static class or a static function. Rebuild push connections. What I could do public static list pipe insert node build insert node list world from position why oh yeah list okay. There. Get rid of that squiggly line. Okay, so a static is a function that you can call from anywhere without needing on it to instantiate a variable, right? So a static is the same no matter what function calls it. It's the same call. It's it's unchanging. So because it's not based on a certain instance of a function or a class, right? BE pipe base, the static is the same no matter where the block is. It's the same call. It's all the same call. So you have to pass the block position to say, hey, a function like this function is unique, or it has access to data, right? That is unique to wherever this function is, right? Whatever block position this pipe base is, it has access to that position. The static does not. The static does not have unique data associated with it. It is the same call no matter where it's from. And it doesn't have to be even called in this function, right? I could create an API like helper, right? I could have a helper that's static that is like, hey, what are you looking for? Right? I could just have it like, what object are you looking for? And there's just node graph whatever, and just really genericize it. I'm not really ready to do that just yet, but so what this does is it will build insert node list. You're going to pass it the block position, right, of what network, like where are you at? And then the pipe insert node itself is going to be built as is. So we also are going to need a list block position checked equals new list block position. We're going to need another one, list block position to check equals new block position. This function is going to be gnarly at first until I can figure out how to optimize it. Okay, and then we're going to do while to check dot count is greater than 0. To check dot add from position. Why is this all squiggly and bad? What? What? What the hell? What the hell happened? Why is this erroring out? Block position is a type. No shit. I'm sorry. What the hell what is going on with this line of code? Why is this not? Whoa. Okay. Oh, I have current project. Not current project. Dear God. Not current project, please. What is checked a is checked an actual like checked is an actual reserved word now? Code snippet for checked block. What? Where is this defined? Since when is checked? Yeah, it's saying this is a reserved word. Like, can I come up here? Yeah, checked. Code snippet for checked block. Is that a C sharp? I'm just gonna look. Is checked a reserved C sharp word? Yes, checked is a reserved keyword in C sharp. Checked keyword is specifically used to explicitly enable overflow checking for int type algorithmic operations. Checked. It is. The checked and unchecked statements. Checked. Uint A equals uint dot max value output to unchecked. Yeah, it's. When did they add this? What version of C sharp did they add this to? This is news. Like, this is news to me. Like, the fact that checked is a reserved keyword now. Okay. So now that we know this, what's a synonym to checked that I can use here? Poked? I don't know. Okay, so we might as well say this is going to be to poke. I guess I gotta make sure that checked is not used anywhere else in my code, because God only knows it's gonna be nasty. Because I do know that 1.22 they've bumped the version yet again of the target C sharp version to like 10, I think. So when I first started, the C sharp version they were targeting was like 6 or 7, and now it's 10. Like, they've way pushed forward because they're trying to convert the entire code base to the nullable context. which that's a massive project. I don't even want to think about right now. Okay, so we have poked and we have two poke. Now we need a similar algorithm to one that I've done many, many times. So like I think the Derek was probably the most recent iteration of this kind of function. I don't need a dangling checkpoint. Validate well. Get first pumpable position. Okay. Okay, so we have God, I have check breakpoints everywhere in here. Build pumpable fluid later. So we have two check cache. Yeah. See, I somehow avoided incidentally the checked keyword. To add okay. Yeah, I just wanted to make sure my general pattern here. I do put to add out here, so I'm not constantly reusing, or I'm not constantly reallocating memory here. So that would be out here would be list block position to add. Okay, so while to poke dot count. Now remember, I'm pulling specific. I'm looking for very specific things, which is other block or other pipes. So, I need to use the bathroom so I can actually concentrate, but I will be right back. All right. Now, we need yeah, okay. 2 poke. Yeah, I wish there was a way. There probably is via hotkey. I wish there was a way to cycle through these. Yeah, so -1, -1, -1. So I'm taking the block position, right? And I'm subtracting 1 from every like XYZ. So I'm getting down 1 corner. And I'm adding 1 to XYZ. So I'm basically creating a box 3 by 3 by 3 that encompasses the block position. Right? And then I want to do a walk blocks. Because walk blocks is a little bit, it's a better thing to use. It's more efficient. So it's like, because the game, what it does is it takes a little copy of whatever the bounding box is, right? And start and end position, creates a little copy of that, sets it aside, and allows you to iterate through a small copy of it very, very quickly. And all it does is it calls whatever you put in here. Right now, there's a delegate. I could put a function in there, right? Because it's looking for an action. Right? The action block int is looking. It's looking for a function that's that. I could create a function that does it, but what it does is like, hey, just call this function for every single one of these positions. Just every one of these. Just do that. The delegate is nice because it allows you to use the variable names that you have defined in the function rather than calling another function, putting that on the stack, which you don't want to do. I don't know how internally delegates work as far as like stack space on the call stack, but I'm hoping it's more efficient. I'm assuming it is. Otherwise, why include the feature? Okay, so the walk blocks, I'm just going to copy this so I don't have to retype it. So this is why we pass in the world, by the way. So we do world.blockaccessor.walkblocks, and we do poke 1, poke 2, delegate block, and then center order, doesn't matter. So the delegate is just, it's a little, you're inserting a little function, just like one of these. You're inserting a little function into this that's called for each block, right? It's giving you, it's calling us for every block. So we want to say if D block, well, we want to say if X does not equal position dot X and Y does not equal position dot Y, and see, okay. I'm pretty sure I most likely do that here. No, It's funny. I don't do it here. I should have, but I don't. Okay. So if those are not equal, which means we're not looking at the block that we passed in or the block that we're processing right now, right? That's the thing, is I want to make sure that we're not re-looking at the same block that we called. Now we need to see, okay, what is this block? If D block equals block pipe base new, okay. Why does it not like that? The is compares types, not equality. Equals is saying, is this block equal to this block? Which it wouldn't be, right? But is it a type? Is it the type of block pipe base new? I'm thinking in like multiple dimensions, because it's like it's gonna matter if is it the same pipe? Is it a different pipe? So how do I determine what face? I think instead of doing this, what I'm going to need, I'm going to need to change this a little bit. I'm going to get rid of all of that. I'm sorry, but this, we're going to do for int f equals 0, f is less than 6, f plus plus. Because we have this here. We don't need to look at all 26 blocks around a pipe. That's a waste. We only need 6. Northeast, southwest, up, down. So we go from 26 blocks that we have to check to 6. Much more efficient. And then we iterate through the faces. I don't know if there's a, let's do world.blockAccessor.walk. Yeah. It'd be nice to have a version of walk blocks, but it's just to the like walk faces. Walk whatever. But this is essentially what this is for anyway. So, so the face, this face here, 0 to 6 are the 6 different directions, right? Where what I'm doing is I'm going to replace most of what's in here with a call down here, Because the static, we're going to be able to use this anywhere, really. And I may end up pulling this out from here if I can figure out like what we're checking for. Basically, pass in a type. Say, hey, what are we looking for? Right? We're pass in like build node list, but instead of just assuming that we're looking for a pipe, being able to pass any type, right? Just like build block node list and just pass in a block type. Like what are we looking for? Would be a much more realistic way of doing that. And I can just put that into the VE helpers class as another static. But let's get it working first before I think about doing something like that. So we have to look at any sides that we override. If f whatever, if well, we need to do right we need to access that disconnected sides. We need to oh now I missed my where is it? Okay. So we need to grab BE pipe base new BE pipe equals world dot block accessor dot get block entity BE pipe base new at position. Okay. If BE pipe was equals null, continue. Like, gotta have a sanity check there. Because if we grab that position and it's not a pipe, then that's a problem. It shouldn't be. We should only have pipes in that list, right? The 2 poke, we should only ever have pipes in there. But just in case something happens, right? In between milliseconds, the pipe disappears or something, like God only knows. So all continue does is it just goes back up to the for each. Boing, it bops back up here and it doesn't just skip it. So if BE pipe dot disconnected sides of F continue. Again, we're gonna skip if the face is disconnected. If we're overriding it, don't even look in that direction. Right? The continue is just skip it. Don't even look there. Else, we want to grab if world dot block accessor dot get block at position dot add copy of block facing of F. Is BE pipe base new. Wait, I can't index pipe block facing of F. Don't I? I literally should do that here. All faces. What? Oh. Uh, Looking at the wrong object. I'm comparing a block to a block entity. Right? So, to add, so we say the to poke here, which is that's the entry point. This is the start of the algorithm. So we say, okay, we're going to add the position that we start with. We're going to add that to the list to check. So the first time through this, to poke will have one item in it, right? So we want to look at it, grab if the side that we're looking at is disconnected, we don't want to look in that direction at all. We don't care. We don't even care what's over there. We want to ignore it completely. Otherwise, we look at that direction and we say, hey, is there a block over there? Is there a pipe over there? Now, do we add it to the let's see. Oh, I want to figure out where to add it to poked. Where the first thing. BE disconnected signs skip. Else get block. If it's block pipe base. I want to pull this. Wow. See, we're already grabbing this. Right? We already have a block entity, that's the pipe. we don't need to compare whether the block is a pipe. If the block entity is a pipe, odds are pretty good that the block is also a pipe. For each block, so we're grabbing ourselves. Okay, so this block is what we are. The first iteration is, okay, what are we? We are a pipe. Okay. So we are a pipe. This is actually looking at what are we connect? Is there a pipe on this direction, right? Whatever the face is. All block faces in the order of northeast, southwest, up, down, which is why we're iterating through 0 to 6, or technically 0 to 5. It's a zero-based array. So we have world.get block. Is it a pipe in that direction? What I want to do is grab this position, and we're going to do block position con direction equals. Okay, grab that there, but then we're going to pass it in to here to make sure that's going to go. But we want to make sure if con direction, no, let's do if poked dot contains con direction, continue. Okay. If we've already checked this, skip it. That means, like, if we're this pipe and we bounce ahead and we're checking this pipe, when the time comes that we're checking this pipe, we're not going to go backwards and check this pipe again, because we've already checked this pipe. We're over here now. We don't need to go backwards. This pipe position will be in the poked, right? We've already poked it. We haven't poked it yet. To poke, right? So if poked contains, we're going to skip it. If not, continue means it's not even going to check this if statement. Continue means we're going to go right up to this for statement, and we're going to check the next position or the next phase, right? Or at least the next phase of the position that we're checking. I know it's kind of confusing, but it's just what you have to do. Okay, so now we're going to get block. If the block pipe base is a thing, we need to do to add con direction, right? We've checked to make sure that we haven't already checked it. We've checked to see if it's a pipe, right? We've already checked to make sure we're not overriding the side. We checked the side. We checked the existence if we've already looked at it, right? And then we check the actual block itself. We want to do this very last because this is, a slightly more expensive call, because we're not accessing memory that we have just locally here. We're actually having to go out and say, hey, what block is there? So this is done last. And then if it passes all of that, then add it right to the list. After we've added to the list, we're going to come out of this for loop, which is what we're looking at, and we're going to add it to poked. Right? We're taking the position here, having gone through all of the faces, all 6 faces. We've looked at all 6 faces, gobbled up whatever whatever positions that we need to gobble, and then we're going to add the position to poked, which when the thing comes around again, we should have at least one. The second time it's called, we should have at least one value in or poked, right? The to poke, right? This we have to then change because we're iterating it through this for each, and you cannot alter a list in a block that is iterating through that list. Okay? So you have to, outside of the for each, affect the to poke. You cannot address it in the for each here. I couldn't just dynamically keep adding blocks right to the to poke. I can't do that. You have to do it outside of there, which is why we have a to add here. So then we do if to add dot count is greater than 0, right? After we've bombed out of here, we go to poke dot clear. We're going to clear the list that we were just iterating through. We're going to clear it. Then if there's something to add, we go to add dot add range to poke. If to add dot count is greater than 0, we add we need to do to poke dot add range to add. There we go. I got those back. So we're taking the positions that we need to check. We're clearing that list. Then we're adding all the ones that we just came up with. Right? So as this thing spiders out, it's gonna spider out in all directions. Whatever is defining the conditions. It's not gonna check the same place twice, but it's gonna branch out. And, it's going to check this block over here, and then this block over here, and maybe one up here, and maybe one down there, and then do the next iteration. And it's going to do all of that again. Hopefully fast enough that I don't have to thread this out, because that would be a fucking nightmare, threading this out. So to add dot count, right? We're going to add to poke. That's what the while loop is looking at. We're going to add that, come up here. It's going to be like, oh, we have more. I need to then clear to add dot clear. Right? We clear the two pokes, basically to check. We clear that list. We add any that we need to add, and then we clear the add. Right? And then we come up here and we're like, okay, we have maybe 3. We have a count of 3, and we need to iterate through all of those positions, but we have to be able to ensure that this poked doesn't change. This is our master list of all of the ones that we have. Okay. So build insert node list. So what this is actually looking for, when we check, we have another thing that we have to do to this, right? Because we're not altering the output at all, right? Build insert node lists. We're not actually looking to see if there's any insert nodes. So now that we're in here, the get block here is the pipe insert nodes, right? We're checking to see if it's a pipe. What we need to also check, right? And in addition to adding it, we need to check the block entity. If, let's see. This is where this is where it would be handy to keep that Boolean for insert sides. It's just a really fast way of iterating through. but it's kind of redundant. It's very handy when I build the shape, though. Having just booleans of all the faces, I'm able to build the shape pretty fast. So if disconnect decides else, so we need to look at if be pipe dot insert sides of f I might need to do this outside of this else. Because we're still iterating through the faces. But I want to make sure I'm iterating through, not nested into the check of the next block. I'm checking the block that we're actually processing in that moment. If BE pipe base of that side, we're still iterating through all the sides. If the insert side is true, then we need to do output dot add new pipe insert node block position, we have that. Block facing, oh, I hate when it just does that. Subnet distance. I'm going to put 0 there for now. No, what are you doing? 0. Thank you. Oh, we need another one. So this is adding if the insertion node is valid, if the side has an insert node, create a new insert node object to the output list. And then as this iterates through, it's basically bouncing from pipe to pipe to pipe, and it's adding these insert nodes as it goes along, right? If the insert node of any direction, like if you have no insert nodes on a network, this will never trigger. But this list is not every block position. It's just every insert node. And then when we finally finish, when it's all done, it has no more pipes to look at. Then it will return whatever insert nodes it finds. The distance, the reason why distance is 0 to default is distance is relative to whatever position called it. Right? Yeah. So up here now, so this is basically done. We pass in the position and we get out from this. Why is this? This is like dark. Why is this dark? Let's clear the list. To poke.clear. To add.clear. And then poked.clear. Just, just in case, cleaning up that memory a little bit. Because we don't need them anymore, right? We've got the output, we've got all the new insert nodes. We've already kind of position.copy. We want to make sure that anytime we use position, we copy it. Get block entity, that's fine. Because a block position is a complex object, it's passed by reference. Anytime you pass it into a function, it's passed by reference. So if that reference changes or disappears, the where you add it also changes, right? So you always want to do .copy unless you there's one instance where I actually don't do it on purpose, but it can cause innumerable problems if you're not aware of that. Like it can cause huge amount of problems. All right. Now we have, let's see. Up in our original call, rebuild push connections. How do we want to deal with this? Yeah, see the pipe network stuff? This is all going bye-bye. So what this does is it calls our static, right? Passing in the position, right? This is the unique position to this, whatever instance is calling it, passes it into here, and says, hey, build me a list of insert nodes. Grab that list. What I want to do, if insert nodes.count is greater than 0, insert nodes.clear. If insert nodes equals null, insert nodes equals new list. That might not be needed because this is going to get a list that's already instantiated, right? The output. It's going to get that. I might not need this. Well, we'll see. It's going to be a week or two before I'm actually able to test any of this code. This is the hard part about like the difference between like modding something and creating something is sometimes you do a whole bunch of code when you create something that you don't really know if it works or not until you actually can start going in and running it and seeing if it works. Yeah, this call isn't good anymore. I don't even know where I was. There it is. So we don't, while it's not giving me an error on this code. The problem is because this is now a list and not an array, indexing into it, because I'm trying to save memory, right? So it only will have objects in there in the list that actually exist. So if extraction nodes equals null, return now for each or extraction nodes dot count is equals 0 for each if node dot face dot index if node dot face code. Oh. Okay. So yes, it complicates the finding, right, of the node. I don't know, and I honestly don't know if this is more memory efficient or not, but I would imagine if you have, hundreds of pipes in your world, not having, an array of pipe, like empty pipe extraction nodes, right? You have 6 pipe extraction nodes per thing. Like, I would imagine it's not as memory efficient if you have, even if they don't have anything in them, it's still an amount of memory that's allocated. Versus just something that's null, doesn't take any memory. If face index that we're passing equals, so we're iterating through all the extraction nodes, right? We have already checked whether extraction nodes is null. We already checked whether extraction nodes.count equals 0. So if neither of those are true, if neither of those are true, then do a for each on the pipe extraction node list and compare the face index with the actual node face code, right? So we're saving the actual text northeast, southwest, up, down with the pipe extraction node. We're saving that data. So we have to convert it back into a facing and then grab the index of that, which is, I want to say that I have somewhere something that does that for me. I can't remember if I like face code face. I can't remember if I did it from face, no, from code, no. It's weird. I thought for sure I had a function somewhere. There it is. Convert index to face. Ha! Okay. I knew I had it somewhere. Convert index to face. Okay. We're passing in the index. So if face index equals node.face code. So if we do a convert in here, this wants an index 0 to 5. Convert index. Okay, so if we do this, yeah. So block facing face equals convert index to face of face index. So this is converting it into a face. If node.face code equals face dot code. Right? The face is a block facing object. Face code is actual the string, right? It's the code of the face. Everything in the game has a code. It's a code, man. So for each node, if face code equals face.code, now I need remove extraction listener. Oh. Remove extraction tick event. Extraction. Well, I can just do node dot listener ID. Okay. And then node dot listener ID equals 0. So it's a roundabout way of doing it, but I'm hoping it's more efficient. Like somebody could tell me like this is way not more efficient than just having a set array, but so we have many more red Duvallakis here. So the rebuild push connections now. We're just needing to pass it the world. Num insert connections. Now, is this the number of insertion connections for the entire? Okay. So the insert nodes, they're saved per block position. So if you have a node that has 3 different extraction nodes in it, right? The insertion nodes, the list of insertion nodes is the same with all 3 extraction nodes because they're all in the same block position, right? If you have a pipe that has 3 different directions that are extract nodes, it doesn't matter where the positions are, where the insert nodes are, they're still the same distance away from that position. That doesn't matter. The extraction nodes themselves can have different data, but the list that it actually needs, the insert nodes, that is the same, right? That'll be the same thing, the same list. And the distances as well. The distance is still the same. The extract nodes just treat that differently. Okay, so we're going to come up here and say we're not going to care about the network ID. We don't need that anymore. Num insert connections is greater than 0. Why? Why am I num insert connections greater than 0? Okay. I don't actually understand what this is doing. quick network update. Yeah, we're gonna. I think what this essentially is trying to do, if it loads from disk and it has connections, then it needs to tell things that we have connections. But I'm going to, because all this does is inform the network. We don't need it. There will be no network. Same with this. I do have an extraction sides. Why? I have an insert sides and an extraction sides. Connection sides. I do a ton of like debug output for this because it was a nightmare trying to debug this feature. Insertion connections, extraction connections. Num insert, num extract. This is I'm already outputting number of insert and extract connections. I don't know why I need to then output num push cons debug. I don't know what these two values are for. I think these are, this is data that I send to the client, or at least I was going to do it temporarily because it's like most of the processing for this feature is done on the server. The client doesn't care about any of these values. So like tick handler, all that kind of stuff is like it doesn't need it. But yeah, it is what it is. On player right click. So this is pipe connection. This is when you change a node from like insert to extract or back. God. When there's no space there, boy, the game does not like that. Or the UI does not like that. Pipe insert node. Hmm. being able to index into the list of either extract or insert nodes by the face index would be really handy. Face index. Pipe insertion node. Con to remove. So what connection are we going to remove? Do we even care about this? Does it even matter? I don't think it does. Because we're not... This is being sent to the network to update. I don't even think we need... We just need to clear the connections. So what I could add to this object is the very same sort of command, like just quick remove an insert node. Right? The position and block face, right? The face index. Because it doesn't matter what it is, it's just like let's spitball this a little bit here. I'm thinking instead of a list for the extraction and insert nodes, instead of a list doing that, do a dictionary. Because a dictionary would allow me to include an indexable int to the actual object. It'd be int object. And that would allow me to then index in using that int without, like, let's say there's just one extract node on the down. Well, that's index of 6. I don't need 5 other things in the list to get to the 6th one. Right? In a dictionary, there would just be one item, but the ID would be 6. And it would, object of 6 would be a dictionary, and it would return the actual pipe node. That would be the better way of doing it. It just gets a little gnarly when you're trying to save stuff to disk. But even then, I could write a quick function that convert dictionary to array or something like that, which would just return an array to save to disk if there's anything in there. If not, it would just save null or something. Although I think a dictionary can be serialized pretty easily. There's so many ways to solve these problems. It's hard to know what is the best, most efficient way of doing it. That's what's hard, is what's the best approach. So we have the rebuild push connections. We have the build insert node list. Builds a fresh list pipe insert node. No, I didn't want it. Please tell me that doesn't. Yeah. No, it's not gonna. It does not like using these things. I think I have to do like and less than. Yeah, there it is.
Somebody just said
Yeah.
block attribute.
Block attribute.
Not sure how far back they are in the video though, so not sure if it's relevant.
Yeah, what I'm thinking is, let me just finish my thought here. Right, instead of this list of pipe insert nodes, Jesus, do a dictionary. Oh, if I could spell it right. Okay. Same with the extraction. Dictionary int pipe insert node insert nodes. Okay. And then we have to do that and that. And that, does a whole bunch of other gubbins. But what it means is now with that list, I would have to obviously manage it a little bit more. But for like something like this here, we're given a face index, right? So instead of having to iterate through all of this, what I can do is I can just do if extraction nodes, right, dot has or contains key base index. I can do remove extraction listener or remove tick event, right? And this is going to be, it needs an ID, right? So now we go extraction nodes of face index dot listener ID. We're able to index into that because now it's a dictionary. And now we can do extraction nodes dot base index, come on now, dot listener ID equals 0. And now we don't have to do this. So now we don't have to iterate through the whole list. We just make sure that it has the key, right? A key value pair. We make sure it has the key, because if you don't do this, you can have crashes. And then we can just index via the face. We don't even have to do this. We want to make sure it's not null, that the count is greater than 0, right? If it's 0, then something went wrong. But then we just remove that listener ID from that extraction node, and then we set it to 0, right? So the same thing can be done here. Pipe insert node, so now insert nodes is a dictionary. It's not a list. So now we have to do key value pair node in insert nodes. Then we go node dot value wait, what? Dot key? Oh, I think I have to set int. Oh my, really? Int. Don't assume that it's going to be some crazy ass value. Int pipe insert node. Okay. Now node dot value. Okay. Position dot value. So key value pairs is just like it just returns like the int and a pipe extract. It just returns those value pairs. You can iterate through all the values, right? But in case I need the key, which is the face code, you want to do key value pairs. So list pipe insert node. So I need to do this as a dictionary. And then output there. Output.add. It needs a key, which is literally F, right? So we're adding the index, the face index, 0 to 6. We're adding that face index into the output because it's a valid insert face. We're adding that in, and then we're returning the dictionary. So a little tweak here to this. And now the sort. Shit. X dot value. No. Insert nodes. How do we sort parameter X? So can't sort a dictionary. Insert node dot values. It's a collection containing the values. I don't use this stuff very often, so I haven't fully memorized how this works. This is another great use. How can I sort the dictionary by a value in object? I need to change it. Oh no, I already do this. Value.set distance. Okay. Oh. What? Let's do. Hmm. Okay. So the distance is, if you have an extract node on one side and then you have an insert node on another side of the network that has a bunch of insert nodes, like one space that has a bunch, the distances will always be the same for that. So it's kind of wasteful, but I'm like, because it's a single block position, but the position itself will be. You could have 3 insert nodes that are all the same block position. The distance is going to be the same for all of those. Okay. So rebuild push connections. Insert nodes. We already clear it. Insert connections. We set the new amount of connections to the new list. We clear the list, clear the connections, set the number of connections, iterate through the list, setting the distance. Finally, sort by distance, Return it to a dictionary. There's our new insert nodes. Clear the temporary nodes. We're done. So now we need public void remove push connection world what pipe insert node to remove. So yeah, I think this is wrong. I went down a rabbit hole here, and I think the insert nodes let me look at my extraction node really quick. What data do I have with this? We have a list of insert nodes here. This is not used anywhere? I find that hard to believe. Not the entire solution. Jesus. Current document. I don't use that anywhere? This is going to be a problem. Oh, there's so much to do. Where does this grab? Okay. Connected to transport tick. I'm trying to find where push slot. There it is. Get push slot. Pipe base. So block entity, push connection. VE pipe base. Where's VE pipe base dot push connections? Okay. So we've changed that to num insert connections or insert nodes. Okay. I'm thinking right now, like, how do I want to approach this? Because the extract nodes, I think for each position, which is what this is, the insert nodes and extract nodes, to keep as a dictionary, this is what's right. Right? This is like, what insert nodes does this individual block have? Not what all the blocks are. Right? The entire network. That I was sort of like going down into the weeds on this and thinking the insert nodes was the list of all insert nodes ever. And it's like, no, this is just, what are the insert nodes for this specific block position? Okay. So this insert nodes is what block face, and give me the, like, what insert nodes on the what block face. Doesn't matter what they are. The insert node itself. Okay, so now the calls that I was working on, somewhere in here. These I need to change these again. These have to be a list of just all the build insert node list. Okay. I still don't know why this is sort of grayed out right here. I don't understand why it does that sometimes. It's almost telling me like, hey, this isn't used or something. It's just weird. Build insert node list. Builds a fresh internally given a starting position of all insert nodes in this pipe system. Okay. So we return that up to here. Rebuild push connections. Now again, our insert nodes is not something we want to edit. Oh, I wish this IDE cleared trailing spaces. Something as simple as clearing the trailing spaces. you'd think would be built in, but I've yet to find a place for that. Like there's a couple like weird add-on libraries that do it, and I'm like, no, I'm not going to go down that road. So rebuild push connections. Here's the problem, like the extraction nodes need to hold their copy of the insert nodes because they can sort it differently, like whether it's farthest first, nearest first, it needs its own order of operations. So each extraction node is going to have a copy of all of the all the insert nodes. Hello, I just found, is it known what they are for my pipes? Do you use the pipes to move the things? the items and the items and fluid. I mean, they're already in the game. We're just redoing it. We're trying to make it better. Trying to make them less derpy. So, rebuild push connections. Rebuild push connections. This grabs the list. All this does is build a list. It doesn't do anything with the distance because we don't know the distance. this, we probably want to return the same thing, right? Why did I? Oh, yeah. Not all code paths return a value. No kidding. So let's grab list of this. So we grab the list. We're not going to do this. It feels like I'm like doubling it up. I think I need to remove this altogether. Something tells me I need to remove it completely. Like that. Because we need more red. That's right. We need more red over here. And I usually try to end my development streams to be able... I usually try to end where I can compile the code, right? Where it's a there's no errors, right? I don't think we're going to get to that today. Almost this entire file is just one big error. So initialize all. Now what we're doing, see, what I'm stripping out is the need to constantly rebuild a network like thing. So num extraction connections greater than 0. What this is doing is saying, hey, I need to rebuild push connections. Okay. So let's go back. So now that I know where this is called, this is rebuild this pipe blocks push connections. Now, normally what I would want to do, oh Lord, that's going to be a function and a half to update. Ooh. So this initialize pipe extraction connections. What I want to do instead is if we have extraction connections, we want to do we have a variable in here? We have shape dirty. We want protected bool. I'm trying to refrain from calling it a network. Graph dirty. Well, let's public. Oh, Jesus. So, if true, extraction nodes on this position will rebuild their insert node lists. Okay. So, if we have extraction connections, graph dirty equals true. Right? So we're initializing everything. Initializing the extraction nodes. Extraction nodes.f. Okay, that's fine. Mark pipe dirty. This I might have to remove. Let's go to definition. Oh Lord. Yeah, I'm definitely going to have to redo this function. Holy cow. Rebuild the connection directions for when a neighbor block changes. Okay, so this is probably where the bug is, that it forgets when you're on a chunk boundary, it forgets that you've overridden because it's looking at this going, oh, I'm going to mark this dirty. And so when it loads up if you have one chunk that's loaded that has a pipe on it, and then the chunk next to it loads that also has a pipe. Well, if you've previously overridden that pipe connection, it shouldn't connect, but this function could override that. There's probably something in this rat's nest of code, right, that's ignoring it. But what it does try to do, because when you override the connection on one face, it has to tell the other face it's overridden on its other face, right? So it's like if you have two blocks that are side by side and you override the connection on one to disconnect it, in order to update the shape properly, the other pipe also has to have a disconnected side, right? So it's like both sides have to be disconnected. So yeah, that is going to require some shenanigans. Yeah, I'll have to comb my way through that. So that's the thing. So graph dirty. Okay, let's go back. Let's go down to the next thing. On player right click. Yeah, figures we won't have an easy thing to do. So obviously the pipe network is going to go away. So we're right clicking the thing. Do we right click it with a wrench? Are we sneaking? If sneaking, remove add connection. So if insert sides of the index, which is what we grabbed, right? So how I built this is why when you look at a pipe, all of the different directions have a collision, like they have a selection box, because I set the selection boxes. So the first 5 or the first 6, 0 through 5, the first 6 boxes are the order northeast, southwest, up, down. So that's the index, and then the 6th square, the 6th selector thing is the center, right? So if face index equals 6, which is the selection box, if it's 6, that means they click the center of the object. And this allows you to directly interact with the center, aka like break the block. Because the other 5 or the other 6 selections, I know it's confusing because it's a 0 based, but the other 6 faces are very, very particular. Northeast, southwest, up, down. They are hard coded. So I know exactly what you clicked on. Now, something could be said, now that I know how this works, I could just set one box for the whole pipe. And then you interact with whatever face it is. That's another way to do it. That's how the pipes mod works, is to re-enable a face that you've already disabled, you have to right click the side of the thing that you disabled, and that'll re-enable it again. But this way I'm like you interact with it on a very specific area, and it always is available. So if insert sides is true, side valid, what am I doing here? Insert connections minus minus. Insert sides face index equals false. So we're essentially disabling it. Pipe insert node conda remove. Why don't I just remove it? What is this all about? How about I just go insert nodes dot remove face index. Okay, so this removes the face index. The insert sides, this controls the shape, right? So we're setting it to false. Insert nodes. We're not doing any of this right now. Now, if the extraction sides of that and extraction nodes of face index does not equal null, which it shouldn't be if the extraction sides is good. This should be an else if. It should not be possible to have an insert side and extraction side with the same thing. So if this is true, it shouldn't be checking this one. Side, I don't know what side valid is supposed to be for. Like what? What's all that about? Okay, so if this is true, that means we have an extraction node. Now we're trying to remove it. So extraction GUIs. Oh. Remove extraction listener at face index. Okay, I think that should be okay. Extraction side of face index equals null. Extraction sides of face index equals false. Num extraction connections minus minus. Network doesn't exist. We don't care about it. So extract connection sides of face index. So, again, we want to else if. Connection sides is a special. This is what's between two pipes, right? You're not going to have insert nodes between two pipes. It's not classified as an insert node because the pipe does not insert into another pipe. It's a connection, so it's a pipe connection. Connection sides equals false. now I want to opposite face, right? We grab the opposite index. We grab the pipe, right? That is git block entity as BE pipe paste new. What? New. Okay, now we're overriding the pipe connection face, and then we don't care about the network. Okay, and I'll deal with how to update things in a second. So we have if disconnected sides. So if insertion sides, if extraction sides, if connection sides. Now if we're on disconnected sides, these are all mutually exclusive, so it shouldn't be running one of these for everything. Mm-hmm. So here's the catch-22 that I just ran into. Imagine you have two pipes next to one another, and they're connected, right? So connection sides, say it's north-south. So the connection side of north is true on one, and connection side of south is true on the other. And you go in, and you override it by shift right-clicking with a wrench, which calls this else if connection sides. It's saying that's true, right? The north side is true because it's connected. This goes in and basically says connection sides of north is false. What this should also do is set the manually disconnected sides. So what I need to do, disconnected side, is we want to rename this overridden sides. Actually, I want to do that. I don't want to rename it globally because the old object, the old BE pipe base, it might rename those as well, and I don't want to do that. I just want to do this. Okay. Overridden sides. Okay, it didn't. Excellent. Okay. So if overridden sides. So what this does, if connection sides of face index, side valid, I don't know what side valid is supposed to do. So connection sides is false. Overridden sides of face index equals true. Oh. And not. So this is saying, hey, if connection sides is true, which means there is a connection, side valid equals true, right? Connection sides of that index now equals false. We're saying no to that connection. And we're also setting the overridden side to that index to true. Then we're saying opposite face, we're grabbing this, and now we need to go to here to make sure. We want to go to definition. Overridden sides, we're overriding that. Connection sides of this and this, then connection sides equals false. Okay. So this is saying the connection side, if we're setting this to false, right? Then this call is in the other pipe. We're in the other pipe's domain now. And we're saying, all right, this overridden side is now the new value, which is false. Connection side would be true. So connection side, and like this is true and false. If connection sides of face index, this would be true and false, which would be false. Overridden sides of face index equals new value. Okay. So, because this is called both when you enable it and you disable it. So overridden sides of face index equals new value. So it's enabled or disabled, true or false. If connection side of face index and new value true and false, not. Right? If connection side of the index and the opposite of what we pass in are the same. So if true and not of false, which is true, if this is true, that means there's a mismatch. We are trying to override the connection, and what we are right now, connection sides, let's say we're disabled and we want to re-enable. That means the overridden is true. We're passing in true. So overridden sides, bool sets the overridden value for the given face index. Okay, so overridden sides, we're saying when we send it in, we're passing in true, which is saying overridden sides is true. Connection sides, which is true, and true, which is true. So that is right. Connection sides equals not new value. So then when we go back and we re-enable the face, overridden sides is false. Right? Bool to set the overridden sides value for the given face index. Okay. So we pass in false because we're like, oh, we're not overriding it anymore. We want to return the connection to normal. So now this is saying, all right, this overridden side is false. Connection sides of face index, which would be false. New value is false. So now the connection side would be set to true, which would be right. Shape dirty equals true, which is what the shape dirty rebuilds the shape. So, I might need to get rid of this mark dirty. This might be superfluous. The shape dirty, it should redo it, but anyway, I'm going to leave it for now because it is what it is. It's not the problem I'm trying to fix right this moment. So yeah, this should then be able to re-enable that face. If connection sides and new value. So if this is false and this is true, or this is false, then we need to set it to true. If this is true and this is true, then we need to set it to false. Like it's kind of confusing, but I don't know 100% if we need it. I needed a way to save that a player manually wanted to override something, right? That it wasn't just like the game generate, like these two pipes are connected, like they're connected, like they're next to one another. The algorithm detects, hey, they're connected to one another. You should have a connection there. So the game itself, or the mod itself, says when you place a pipe next to another pipe of the same type, they connect. And then when you go in and manually disconnect, I needed a way to save that, because if I just set connection sides to false and then the game loaded back up, it would see that the pipes are the pipes are next to one another, and it would connect them because it would be like those are next to one. So it should be checking that overridden to make sure it is. Okay, so going back to here, override pipe connection true, because we are connected sides. This is true. Else if true, right? That means we are connected. Override the connection and set this to true, meaning we are overriding. It's setting the overridden side. Okay. So this connected side is proper, and we set this side valid equals true here, saying we are changing something. Because remember, the overridden side of face index equals true now. So this call, if we just left it as is, this would always be true in this context, because we set it to true. So this is actually saying, hey, we want to make sure if this is true, we've overridden it. This it shouldn't take. Now there's an else if here. It shouldn't do this anyway, but it should skip this because it's an else if. So it's else if this. Well, this will run, and then it should come out to mark dirty. But the not side valid means, hey, if this is true, it sets it to false and doesn't run it. Overridden sides is false. The network we don't care about. We're going to do that. We not care about the network. I want to see
An update from Renegade.
Now you know how I feel a little bit when it comes to stuff like that. Okay, so let's just figure this out. What did I do? Why is this telling me now suddenly I don't... Am I missing a bracket somewhere? Yeah. That usually... When that happens, it's usually like you have a bracket in a weird place, and it's foobarring the interpreter. 7 hours of trying. Yeah, that sounds about right with SE. There's a lot of shenanigans with SE. The stuff is. So this is why when you mentioned like when you mentioned the teleporter. And you're like, at least it was an easy fix. This is why I was like, sure. Sure. It was an easy fix. Okay. So this is a little bit more complex. Because you can override any side, right? So if it's an insert node and you've overridden it, this is why the network is involved. This is why the network was involved with these two faces or these two calls. So we need to inform all extraction nodes of the change. Okay, so this I didn't realize. Now you understand. I mean, you know, we learned something new today. It's always nice. BE pipe paste new. BE pipe paste new. Overridden sides. Okay. So this we now want to opposite face. We need to check because if the other block position.add copy, yeah. If BEPB dot override connection face op face new value false, right? So if the face is a pipe, right? If we overrode a face or a direction that was towards a pipe, then we want to go ahead and say we want to reconnect, right? We're reconnecting to that pipe. Else, we want to check, can we connect, right? The generic can connect to is looking at, right? We're passing in the block position towards that direction. Let's say it's a machine or a chest. We're passing that block position and we're converting index to face. So we're looking at the opposite face of the block. So if you have a pipe next to a chest, right? You have a pipe next to a chest and there's a connection. This direction might be north, but this direction is south, right? That's what you're doing is you're saying, hey, can I connect to the south face right, of this, because I'm on the I'm on the south side of the block. I'm actually trying to connect to the south face, because a lot of the blocks in the base game are very directional as how you access them, right? So something like a chest, vanilla chest, you can only pull, right? You can only extract using the bottom face of a chest. So that's a specific case, but there are certain things that allow connections only in certain directions. The pipes are a little bit more forgiving on that. In general, the pipes look for, can I connect, right? And give me the slot that you can connect to. And then there's some overrides for like chests and stuff, because vanilla is a little too restrictive on that. So if we can connect, right? Can connect to, then insert sides of that index is true. Num insert connections plus insert nodes dot add f face index new pipe insert node and then we do position dot add copy convert what? Oh. Wait, I'm all discombobulated here. It is block position position dot add copy and then block facing then subnet, then distance. Whew. Okay. Right, so we're adding the insert node and the block position of it is the block we're connected to, not the block we are. Okay. Convert index to face. Which we do twice, unfortunately. I should just... I should just make one of these and just... little efficiencies like that. I like doing just because it's easier on my brain. So insert nodes, we're saving the position, we're saving the face, the direction. We're not saving it by default. There's no subnet and there's no distance. Okay. Overridden sides. So we're reconnecting inform all traction nodes of the change. If side valid, overridden signs. Oh, okay. Yeah. Yeah. That's what this did. Side valid equals true. Else. That's why I didn't do that here. I don't need that anymore. Not really sure why I did this though. Side valid equals false. Side, I should just name this side overridden. But yeah. So if we're re-enabling a side that we already overrode, this would be false. This would be false. This would be false. So it's coming in here, overridden side is true, and not false is true, comes in here and says, okay, overridden sides is now false. Now we grab the opposite face, and we get a block entity in that position. And if it is a pipe, right, then we want to re-enable that pipe. If it's not a pipe, right, if this is null, then we want to say, hey, can we connect to that? And if so, then it always defaults to insert nodes, right? So insert node is true, num insert connections ++, and we add an actual insert node with all the default values. I'm looking at this going, we may not need distance, but I'm going to keep it there because I think it's going to be useful for when we have to update when we have to update the extraction nodes, we can give it a list of the insert nodes, and then it'll keep a list of insert nodes itself with the distances encoded, right? We still want that. Mark pipe dirty. What is this else on? Else is not a sneaking. So if we're not sneaking, insert sides. Okay, so swap connection. If we're an insert, we want to swap it. Because shift, like sneak right clicking, is literally to disable the thing. I might have to revert this. Yeah, I didn't realize if you shift right click and insert node, it's going to remove it. If you shift right click and extract node, it's going to remove it. I have to call on node removed so it can drop, right? This is what drops the stuff in the node. What, Luce? Oh, now she's trying. I guess she just wanted to tell me she still exists. So instead of side valid, let's do rename side disabled. I just want to look at the logic here. What is going on? Assigned to and never used. Really? It's never used, huh? Compiler? It's never used, huh? I'm pretty sure it is. Used in several places. So if it's insert side disabled equals true, insert sides is false, num insert connections minus minus, remove the insert node. Inform extraction nodes. Insertion sides, base index. Okay. If insertion sides, disable it, remove it, remove it, remove it. We'll get to that. If extraction, remove it. Double check everything. Do it gracefully, but remove it. If connection side, disable it. Disable the connection. Overridden signs equals true. We want to remove that. So we're disabling the connection side. We're telling the neighboring block to disconnect itself. Right? Override pipe connection. If we're already overridden, re-enable it. Overridden size equals false, so re-enable it. Side disabled equals false. I mean, it's already false, but we'll get to that in a second. Int opposite face. Grab the face ID. Grab the block entity. If it's a pipe, then we want to override the pipe connection again to false. Else, if we can connect to the thing, which means it's something other than a pipe, but we can connect to it, then the insertion side equals true, num insertion connections, and then add the insert node with the default values, and then insert or informal extraction nodes. Okay. Now we basically want side disabled. We're basically like, are we disabling the side? Right? If we are disabling the side, which defaults to false, so if it's already disabled, if this is true, we wanna change it to false anyway. Which we do already here, so we can just do like if side disabled. right? We don't really need to do this. This just adds another condition onto the stack, which we don't really need to do. So we don't even really need to do this. Because these are all mutually exclusive. Insertion sides, extraction sides, connected sides, and overridden sides. You should never have more than one of these true at once. It's only ever going to be one of these. Right? So we should be able to get rid of that and still be good to go. Side disabled equals false, which means we are going to be setting this to false anyway. And we're checking the connection just in case. Okay, so mark pipe dirty. Again, I'm not 100% sold on whether we need that or not. So if we're not sneaking, coming down here and we're like, all right, if it's an insertion side, which means we're changing it from insert to extract, insertion side is false, which we're swapping it. Extraction side is true. We want to do extract sides of face index equals new pipe extraction node. And then we're doing pipe extraction nodes equals initialize. Okay. Num extraction connections plus plus, num insertion connection minus minus. These two are really like what I sync to the client to be like debug, just to double check that it knows how many extract and insert connections. Like, what? I heard her eating a snack, so she jumps in my lap just to check for things, and then jumps down to go eat, and then she comes back and is like, she's gonna jump in my lap, spend about 10 minutes in there, and realize she has to go poop. And then jump down again. Do you have something in your eye? Or is it just the light? I think it's just the light. She has this like shiny thing above her eye. And it's like, yeah. You can stare at me all day. There. Yeah. The lap goblin. Okay. Insertion sides. So all that logic is good. Push connection. We want to mark the dirtiness, so dirty, of the extraction node. Lap Goblin has arrived. Yeah. Pipe connection. Push connection list. Build if empty. This will be empty. Do I use this? Not even any purrs. It tells me your heart isn't in it. I don't even get any purrs. What's up with that? No purrs? Yeah. Your purrs give you away, Luce. No purrs means she doesn't really feel it. Doesn't really feel the lap goblin today, I guess. Just covering me in cat hair for no reason. I don't even get purrs out of it. Okay, apply upgrade. Yeah, so I don't use is dirty must be something I just added. Okay. Multi-blocks are already in. You can already build multi-blocks. Pretty big ones, too. I mean, the thumbnail of the stream has one of them. Big old oil derrick. But yes, the mod is based or inspired by immersive engineering. The very first line in the description of the mod on the mod hub is this mod is inspired by immersive engineering. So I wanted to base it off something people might be familiar with, just to give them a little bit of comfort, so it's not completely foreign, not a completely different way of handling things. Okay. List pipe insert nodes. Okay, so now is dirty. We have a position. We have a. Doesn't matter. The face code doesn't matter. But we have a position, API. Everything there is good. Let's go back. We're marking this as dirty. So this is creating the extraction node, right? Which the initialize creates this right here creates the tick listener, which starts the thing ticking. I think what I might do, let's go to apply upgrade. Yeah. So the add extraction tick event, I'm adding a second onto the delay. So it adds the tick, but it doesn't actually tick until a second in. Now I could make this any number of seconds. I should make it like 5 seconds because, but I'm going to keep it there for now. I don't want to change too much. Push connection. We're going to just remove this because we're creating an extraction node. Right? We're creating an extraction node. It itself is going to grab the insert nodes. It will grab all the insert nodes itself. When we marked it dirty already. So the else here yeah. Good thing I gave myself this text. I almost made this an else if. But yeah. We can't do an else if because if this is true, then this is always going to be true, right? So I actually ran into that in the very beginning of this feature. I would right click it, it would turn into extraction node, and boom, it would turn it back in. It's just like it was weird, and so it was hitting it and then doing it again. It was kind of weird, but so this. We're swapping the extract node. We're removing the tick listener. We're setting it to null. We're seeing anything about the GUI. Okay. We're gracefully disposing, right? Because if it's an extraction node, there's a GUI associated with it. Okay, so num extraction connection minus minus, num insert connections plus plus, extraction signs equals false, insertion signs equals true. We need to then we need to then say very similar to what we did up here. Base index. Insert nodes.add. Okay. Update network. Nope. Okay. Now to do update network. I'm gonna make a function that does this, right? Which is why all the to-dos are basically the same thing. It's like I need to make a function that updates broadly. I might even customize the one I've already written because I already wrote it. So if player blah, 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 equals pipe upgrade or player blah, 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 the pipe filter, extraction size of face index, extraction nodes of face index, on right click. That handles the logic of what to do there. If it's empty, extraction size face index equals extraction nodes. Client, GUI, GUI, GUI. Now this, damn, this is going to be GUI pipe extraction. I need to change this. Damn. I knew that there was a problem with trying to do this. So I am going to need another GUI pipe extraction as well. I need to redo. I need to tweak the GUI a little bit to add in the filter or the subnet basically feature, but I can do that later.
Did you see that last message in chat?
Yeah, I commented on it already.
I had to go AFK, so I missed it.
Unblock broken. I should be grabbing this with the block. Unblock placed. Unblock broken. Um, okay. Now, we need to I can tell that I wrote a lot of this code before I really understood some of these objects. But if oh no block selection, I want the variable dot selection box index is less than 6. Return block facing dot all faces of wait. Yeah. If block selection is less than 6, 0 to 5, then return the index. Right? It is what it is. Like, very simple. I could even mark this static. I don't even need the world accessor. Okay. So I need one object or one function to update extraction nodes. So the extraction nodes themselves, right? When I mark one of these dirty, when I mark one of these dirty, I want the option of giving it a list of insert nodes, like unsorted. Public list pipe extraction node pipe insert node. Unsorted nodes. Okay. So the mark node dirty, I want to be able to have a version of this node list unsorted nodes node list is dirty equals true. Do I want to copy? No. So unsorted nodes equals node list. So I'm basically handing off the list to this, right? I'm saying, hey, I'm going to mark you dirty and I'm going to give you a list. This, I've mainly got this, but anywhere that I have this here, why was that indented so far? Inform network. So mark pipe dirty. Well, we'll look at that in a second. How do we want to tackle this? So we're in the block. And if we have a neighbor block change, we already mark it dirty. Dirty shape true. Yeah, we'll deal with this. Okay, now in the mark pipe dirty here, right? We are VE pipe base new get block entity on block placed. So we call the base, which creates the entity and does all of the initialization, which It's all the block stuff. So it's not like, but it is initializing the block entity, right? So do we need to mark the block? Do we need to mark it dirty when it's placed? I don't think so, right? Because how do we detect whether it's loaded or if it's new? I think what we're going to do for the block entity is in the initialize, somewhere in here, the mark pipe dirty, right? We're calling it here, but then we're going to call it from the block as well, which I think is it's the same call, right? So, doubling that up is probably not wise. Um, hmm. I shouldn't need to initialize these. I think I do though. As I'm initializing with the API. Remember, the extraction nodes are kind of like block entities within a block entity. So I have to use sort of the base game like initialize stuff. So I do need to initialize them so they get the API. But then if I go to the pipe extraction node, initialize here, there it is. Right, because it's also initializing the inventory, it's initializing the API position, all of that stuff. Making sure the apply upgrade just right that initializes the tick listener, that does all of that. Everything else I think is solid. Save the subnet. Okay. Well, I think pipe extraction node is one of the few things that we don't have to completely overhaul or make a new version of. Largely they're going to be the same. And the only reason I have a new on all of these is because all of the old stuff I'm not changing. So be able to load a world, break all of your pipes, and translate them, basically just a craft, an upcraft, just one pipe will equal another pipe. So you just be able to translate one pipe to the new, one item pipe to a new version of the item pipe. The old version, I'm basically going to strip away. Eventually, it's going to be depreciated over time. So those who haven't really put any effort into learning what the hell is going on will eventually write to me and be like, I loaded up the game with my version and all of my pipes stopped working. And it's like, well, that's because you didn't break them down 6 months ago and rebuild them like I told you to. I can lead a horse to water, but I can't make them read descriptions. It's going to be very, very obvious in every step of the way that you're going to want to break these down. Break the old ones down and build the new ones. Because if I just change the block entities over, right, if I take the existing pipes and then I change the block entity to be the new pipe, you're going to load your world. The game is going to expect all of your existing pipes to be the new block or the new block entity, and it's not. It's going to be the old one, right? And so it's going to be like I don't know what to do. Like the data doesn't match. So I'm trying to avoid that as much as I can. Okay, come in here, mark pipe dirty. This is going to be a major to do here. So I'm going to leave those red squigglies in here. This is going to be a huge amount of work in that. Let's go and remove as many of these other squigglies as we can. Remove push connection. This is not being called by anybody. Okay, so if it's not being called by anybody, why does it exist? Did I start this for a reason and not not do anything with it? I don't know. Right, this was the shenanigans here. I'm wondering how to optimize this. This one, where is this called? It's just called up here. So two scenarios. One, you set an extract node on an existing network, right? You have a network, bunch of pipes placed, you swap an insert node into an extract node, right? That new extract node needs a list of all the insert nodes. So the build insert node list would be very handy for that. Item 2, scenario 2, something fundamental about the network changes, right? You have either a pipe broken, right? Or a pipe placed. If a pipe is broken and it connected, right? It connected on any side to another pipe anywhere, on any face. I am going to need to grab and update, or at least mark dirty, all of the nodes on that side of the connection. And do that for all of the connections, which is what my split network code was for. This is why I had a network in the first place, because I was trying to minimize the amount of overhead, which didn't really do that. So scenario 1 is all we do is mark. We just iterate through the list, just like we kind of do, right? And we iterate through the list, and anytime we hit a extracted node, we mark it dirty. That's all we do. We walk the graph, right? We walk and build just like we do down here. We're just iterating through all of the pipes in the network, right? Just think of it as a wave. We're just going through. Anytime we hit an extraction node, we're just marking it dirty. That's all we're doing. Then for each of those extraction nodes, the next tick, whatever speed that is, the next tick detects that it's marked dirty, and then calls this rebuild push connections, right, based on its position. Right? It calls this insert node list, gives it its position. It's an extraction node, right? It gives it its position, rebuilds the node, and then every extraction node does that. So you can have many of the same call, right? Because it's the same network. So updating all the extraction nodes will run this function, which is it's a multiplicative problem of performance, because the number of extraction nodes would be equal to the number of times it has to traverse the list. So that'd be like the number of iterations would be n. So if you had 10 extraction nodes, it has to do the same thing 10 times. Right? You're rebuilding the same damn list 10 times. That's what I was trying to avoid with the network, is doing that. So that's option 1. That is the option that very explicitly covers all of the bases, because it's like every extraction node then rebuilds that list. Option 2 is when I run it on a pipe, the algorithm that basically is seeking out all of the extraction nodes to mark them dirty, that algorithm that does that traverses the whole list first, because it has to anyway, right? It has to find all of the extraction nodes. So it iterates through the whole graph. And by graph, you just imagine a bunch of pipes that are connected to one another, right, as one graph. It's just, right, it's just finding its way through that. It goes through all of those positions once. And it manages a list of insert positions, like what block positions are inserts and which block positions have extracts. And I have a list of inserts positions and a list of extract positions. And as the graph is being iterated, I'm just managing both of those lists. Then at the very end, I iterate through every node in the extract list, and I give it a copy of the insert list. And I mark it dirty. Like, hey, you're dirty. Here's a list, right? It's like your wife handing you a list of groceries to go get and saying, we're dirty, go get the groceries. So it's like you're doing 90% of the work already, and you're handing the extraction node a list of all the valid insert nodes. And then the mark dirty event, it picks that up on the next extraction node tick and says, hey, I'm dirty and I have nodes, right? The nodes are there. I have some nodes that I need to update. So use those, right? If you don't have any nodes, then you're going to have to run the same insert node list. You're going to have to run this anyway. So I'm thinking the call to iterate through what I want to do is basically I want to, because I'm leaning more for option 2, obviously. Running through an extraction, like if you have 10 extraction nodes, duplicating the call, the insert build no list, doing that 10 times to get the exact same list, and all you're doing is sorting it by different distances. That's all you're doing. So grab the list, give it the block positions, then the extraction node can just manage itself. Now, if one of those positions is not loaded at any point, the tick on the back end, if there's an insert node that isn't loaded, if the chunk isn't loaded, it should just skip it. That should already be done. It's the shenanigans dealing with the pipes the pipe networks and stuff that was a disaster. It was just a disaster. So with this, I think what I want to do is we want to... What kind of variables do I want? I think this is going to be a void. Honestly. Rebuild pipe graph. I think I want this to be... Rebuild pipe graph. So this is going to be a version of this, right? Okay. Pipe graph. This is going to be a static. Block position, start position. So now, while to poke, yeah. So this is iterating through, looking for the block pipes or the pipe blocks, making sure we're not overriding the overridden sides. We're honoring the overridden sides. Now we want connection direction. Get block is block pipe base. New. Did I not do that down here as well? No, I did. There it is. I have a feeling there's about 5 more places that's going to be a problem. Okay. Play overridden sides, so we if it's overridden, we skip it entirely. We don't even look at it. Pipe base insertion signs, which means like, you know, so if this is an insertion side, then we want to do T insert nodes dot add. If BE pipe dot extract sides of F I think this will just be block position. Right? If the pipe that we're looking at has extraction sides, we don't care how many sides there are, and T underscore extract nodes dot contains, you want to do a not position T extract nodes dot add position dot copy, always dot copy, always. So we're double checking to make sure we're not adding 50 different, you know, not 50, but it would at most be 5 extract nodes, right? You can surround a pipe with 5 squares, right? 5 things, and add extraction nodes on all 5 sides. You could technically allow 6, but if you have a pipe that has 6 sides, 6 connections, and they're all extraction connections, nothing's going anywhere, right? There's no insert nodes, right? Nothing's going anywhere. We are managing a list of insert nodes on the graph, right? We are managing that. Okay, so, but we're keeping a list of extraction node positions. We're keeping a list of all the insert nodes themselves, exactly insert nodes. Do I make this a block position? Like, Transport handler, get push slot. Push connections. So it's looking at the block entity. Push connections. I need to change the transport tick. Yeah. This is going to be... It's going to be more and more urgent that people break all their pipes before the update. It's going to be really hard. All of these objects are all intertwined, right? Because if I change this, instead of looking at the block entity, which shouldn't have the push connections, it's not going to have the push connections. It's going to be based on the block, the extraction node. So what is the extraction node? Right? That is the push connections. So if we go to the extraction node, somewhere in here, there we go. The insert node's here. Okay. So each extraction node is going to have its own little copy of all of the insert nodes that it needs to address or that it needs to work on, which is, it's essentially just a block position and a block face, right? With a little extra data thrown in that the thing is going to look at. So where do I reset the enumerator? Where is that saved? Reset enumerator. Yeah, push enumerator. There it is. This is going to be pipe insert node. So this list, insert nodes, is going to be only settable in this. Well, this will be unsorted. And then you're marking it dirty. And then the tick handler is the thing that's going to ingest and sort the unsorted nodes into the insert nodes. Because it's essentially the thing that runs the tick, right? What is this reset enumerator? I need to just remove this. The whole enumerator, when you're on round robin mode, it is very, very sensitive. If you at all try to change the list while it's trying to tick, very, very bad. It crashes. Because you cannot edit a list while you're enumerating it, while you're in it, or doing a for each. insert nodes. So we have public list insert nodes. Insert nodes. So we can get it. List of pipe insert node objects for this okay. So this, right? Push connections, BE pipe base, new, I need to go to BE pipe base new. Where is that push connections? Where the hell did I put that? I usually always have my variables at the top. Okay, there we go. That's what I wanted. Node dot insert node. This sorts it again. Don't know if I like that. I don't think I need to. It should already be sorted. But is the two, like you take a list, which isn't really a sorted thing, and you set it to array, is it going to be in the same order? Or do we want it? We want to sort it again, right? We're saving the distance. Do we want to sort it again, or is it going to already be sorted? These are sort of like those low level questions. That's like I think it should be in the same order, right? It should just iterate through all of the items in the list and just, take the first one, put it in, second one, third one, fourth one, and it should just fairly easily do that. So I shouldn't need this. Because these are, the sort is, it's a relatively expensive call. It's not super expensive, but then we iterate through the array, which is a little bit more reliable in terms of I want the first element. Then the first thing obviously I check is the chunk loaded, right? Always, is the chunk loaded? If not, continue. Just skip it. And then all the other logic should be okay. And again, we want to do that. Well, no. Yeah, see, that's sorted in the opposite. That's X compared to Y. This is Y compared to X. This just gets the enumerator. Nasty, nasty business here. This just gets a random number. Returns a non-negative random integer that is less than the specified maximum. So this is not including the count because it's 0 to 1 minus the count. So random next is just it's exactly what I need it to be. Also checking whether the chunk is loaded. That's in everybody. Everybody does that. So yeah, they all check to make sure the chunk is loaded. I need to tweak this a little bit and iterate a little bit better. There's a lot of little quirky things that I need to update, but I also need to do the fluid version. But I want to continue on with the shenanigans, all the red lines that we got going on here. So mark pipe dirty. This is again something I'm going to have to do. I'll do the network stuff later, and then moving on to we were working on rebuild pipe graph. So coming out of this, we have all of our insert nodes in the network, right? All the pipes that are connected to one another. Any insert nodes we find, we put in this list. Any extract node positions, any position that has an extract node in it gets added to the list without hopefully duplicates, which is what this does, right? And then poked, we add that to the list. And then to add, we're adding if overridden sides continue, else con direction K if it contains a pipe, if the direction that we're in contains a pipe, because remember we're in one block, right? The block that we're in, we're looking at all the directions. If any of those directions have a pipe, then add it to the add list. Then check our sides. So our block, do we have any insert sides? Do we have any extract sides? Right? We've already added the to add. If we're going to get block, pipe new, to add, we need to say if poke dot contains. Okay, we've already checked that. So if we've already poked it, we don't need to add to it. Right? We've poked it already. So then we clear it, and then so when we get done with this, we should have all of the list of all of the block positions. So for each block position in T extract nodes. Okay. So this then we need to do BE pipe base new BEPN equals world dot block accessor dot get block entity. Oh my god. Block entity of BE pipe base new of position we already know there's extraction nodes here. So for each pipe extraction node, E node, God, stop doing that. Pipe extraction node in BEPN dot extraction nodes. Okay. Pair dot value dot mark node dirty, and we are going to pass it T underscore insert nodes. Can we do a clone? Copy? I guess we do this. I don't. For each block position in extraction nodes, we grab the block entity. We iterate through all of its. It could be 1, could be 4, could be any number between 0 and 5. Well, it shouldn't be 0. It should have at least 1 in there. So we grab the pair, because remember, it's a dictionary indexed by face, and we don't care about the face. We grab the node, which is pair.value. It's the node. We mark the node dirty. We give it the insert node that we already built, right? The temporary insert node list. We give it that. But I don't know, like, I don't know as far as like what goes on behind the scenes, because I want them all to have a copy of this, but there is no like copy. There's no clone. So I don't know. Yeah, I don't know if we have to do anything special other than that. Okay. So when we get done with this loop, we should have two lists. All of the extraction node positions and all of the insert nodes themselves on each on the whole network. So yeah, if insertion sides of F now mark node dirty, we're passing in the list of nodes. Okay. This is its own thing that we want to keep that. Alter push connections. Okay, so this after push connection list was strictly based on the block position, mainly using the pipe is placed or removed. This is not being referenced by anybody. I don't know if I need this. Reset enumerator. Because it's not being called from anywhere right now. I'm going to leave it in just in case something weird happens, but here we have another one that has what, a different set? Yeah, block position altered, pipe connections. That looks like a lot of the same damn code. Why would I replicate that? Overridden sides. Yeah, this is what's called this is what's called from another thing on tessellation. So we return true to not draw the base object because we're we're editing the mesh, right? So we're building the mesh up from the base. We don't then need to then redraw or re-add the base. So we turn true here. But the add mesh data, I don't think a lot will have to be done there, but hopefully not. Reset the mesh if not null. Yeah, a lot of this texture shape shenanigans. Whew, this was rough. This was really rough. It basically grabs all the different connections and dynamically builds the shape. It was fun trying to figure all that shit out. Ooh. Really, really crazy. Tick event. So I pass it. This call is being referenced by either pipe, so 2 pipes, and I pass in the tick event that actually is called. So this is kind of a middleman go-between. Okay, so this should largely be unchanged right now anyway, not until I add the potential filter information, but it works, and then it doesn't. The moment I'm like, oh, just hit tab, then it doesn't work. And it's like, oh, I don't know what you want. Free up memory. Okay, unblock unloaded. Num extraction connections. This is when a call to a chunk in the block entity resides, it was unloaded, right? So you always want to call base because it automatically removes the tick listeners, because that's why we register them up here. Register game tick listener. This returns the ID of the listener, but it also registers it with the game, right? So it automatically will remove it if it's unloaded. which is why you want to kind of use the game's infrastructure to do that. So in here, if num extraction connections is greater than 0, we want to clear its list. For each pipe extraction node in extraction nodes.values node dot insert on block unloaded. Okay, we go to extraction node. Clear the list. Called when the chunk that contains this node is unloaded. There we go. Jesus. Blah, blah, blah. Now I'm hoping if push enumerator does not equal null, doesn't like that. Does not like that at all. I guess we can just directly call dispose. We want to dispose of any enumerator that we have before we clear the list, because that would probably throw a nasty error if we didn't. So we want to make sure we call the extraction nodes on block unloaded, just in case there's anything more that we have to do. We dispose of the mesh, and then finally we call the base, which removes the listeners. On received client packet. Okay. Extraction nodes of push enumerator equals. Why am I calling that here? Why am I not calling that on the extraction node? Yeah. Why am I not just doing that? That makes more sense to me. packet ID 103. I have some custom packets in here, but it's like these lower level IDs like 1000, 1001, 1000. These are all like base game packets, and they have to do with inventory. So when you have inventory events, it will call these packet IDs. So you have to handle these packet IDs, right? If a client changes something about an inventory, you get these IDs that kind of validate the process a little bit. Okay, so we're going to strip out network ID. Extraction sides. We grab that. Well, is there a way tree.set bytes something? I mean, there is probably a way to just I don't know, to convert the entire dictionary into to serialize the whole thing, but barring that, extraction sides of F could probably do this a little bit better. If num extraction connections greater than 0 for each pipe extraction node, E node, god damn, did it again, in extraction nodes dot values. Tree attribute node tree equals new tree attribute node dot to, what am I doing? Node e node dot to tree attributes node tree tree dot add set bytes. Oh, set bytes extract dash plus enode dot face. I don't want the face code. Well, face code is probably fine. Extract north. This is basically what this will turn into. Right? Comma. Node tree dot 2 bytes. Okay. So it says, hey, how many connect? It would be probably even better to do extraction nodes.values.count, but hopefully the number of extraction connections is tracked right. Basically iterating through the list and saying, hey, extract dash north, extract dash up, just encode the data that's in the node. Extract node, right? We're converting the tree attributes of the node, or we're converting the node into tree attributes, right? And then we're converting those tree attributes into bytes, and then encoding that to the bytes. And we need to do the same thing with insert, because we could probably do the serialize, like serializer util dot serialize of, yeah, this thing wants just generic data. It could probably handle a dictionary, but I don't know, a little bit of experimentation there. If num insert nodes greater than 0, we want to do the same thing for each pipe insert node inode in insert node dot values tree attribute node tree equals new tree attribute inode dot to tree attributes tree dot set bytes insert dash plus enode inode dot base. Think it's facing? Dot facing. The pipes block face. This connection is on. Yeah, I think that's right. Node tree dot 2 bytes. Okay. So then down in push connections, this goes away. Well, I actually push connections. Push cons. Insert nodes. Dot count. This is just the number of insert nodes. Okay, so the from tree attributes, now take that away. Extraction sides, that's just a bool, that's fine. Extraction nodes, well, this again, we want extraction nodes. So num extract, num insert, we are passing. So I don't need that then. So we want to actually grab num extraction connections equals tree dot get int num extract num insertion. Whoa, not what I wanted to do. No, God, really? You're gonna bounce me all the way to the top of the screen. I just num insert. I want the lowercase one. Num insert. So now, if num extraction connection is greater than 0, extraction nodes equals new dictionary yeah. It would be helpful just to directly write these out. Just serialize the whole damn thing. But I'll do it nitpicky first before I experiment with other things. If extraction nodes dot count is greater than 0, if extraction nodes self does not equal null and is greater than 0, extraction nodes dot clear. Because if we're getting data from the server, right? This is what this called also does. It gets it from the server. We want to make sure we clear the list before we start adding new stuff to it, or we do a new. We want to be able to clear it. So clear else new dictionary. So if number of extractions is greater than 0, and this is true, right? If these are true, that means we already have some data. We just need to clear it, right? If does not equal null, let's do that. And then do another if inside. Just because I want the first null check. If it's null, then we knew it. If it's not null and we have some in it, right, then we clear it. Otherwise, yeah. Okay. So this here, we go away. Now the important thing, the extraction size is important, right? Because that will dictate the code that we're trying to load in. Because the face code, it's indexed by face code. So we need to actually know what to look for, which is where the index comes from. So we have for int f equals 0, f is less than 6, f plus plus, if extraction size of f, which means this is good, string, well, we have extraction nodes dot add f comma pipe extraction node enode equals well, I already extraction nodes of f. Pipe extraction node enode equals I want to say this is from tree attributes was calling the old pipe extraction node. So the tree right? So this This is not a tree attribute, so now we need to do tree attribute dot create from bytes, and then pass that in, and that should be the call. It's kind of a doozy, but enode. If, well, I'll have to deal with that on the other side. Oh, I need to add a world. From tree attribute here, I think. World. Yeah, there we go. It's an even longer call now. So that was a roundabout way of getting all of the extraction nodes. It's a little hokier because, of course, we're not saving we're not saving blank ones for faces we don't need or use. So that way, every single block, every single pipe, is not saving a list of nodes that it never ever uses. So yeah, so this clears the list. This doesn't. Right? This is just like, hey, if the extraction nodes of F does not equal null, that might be the better way to do it. Yeah. Let's do it. Let's do that. Ugh, this is ugly. This is so ugly. Because this not only creates it, it also initializes it. Because remember, we're kind of doing the things that the game does automatically for us, because these themselves are little itty bitty block entities within our block entity. So we kind of have to initialize these like the base game does for us. But because it's not aware of these little block entities inside of our block entity, then we need to actually initialize all of this stuff. But I'm wondering if we're on the client, if we're just basically clearing them first and then re-adding them, right? The client is not going to be doing anything with lists. It's not going to be rebuilding lists. It's just aware that the extraction node exists. It's aware that there's data associated with those extraction nodes, but it doesn't need a huge amount of heft under there. And if it's loading it from disk on a server, right, it creates it. Yeah, I don't think this code is wrong. But we do need to initialize it. But we need to initialize it in our initialize. Doing it here, not good. Like depending on it being done in here is not good because it could not run, which would be a problem. So we want to go to our initialize and actually do it there. So I don't need these two because I'm already pulling these in. So we're pulling in the insert side. So we need to do basically the same thing down here. And instead of doing num insert or num extract, we do num insert. And we do insert nodes. Insert nodes. Insert nodes. Insert nodes. Insertion size. Pipe insert node. Okay. Yeah, mark pipe dirty is going to be a process. But and then we need to go to the initialize block somewhere up here. There it is. Here we initialize them. So this is what I need. Like I wanted to make sure that this was in here, but yeah, this is where this is a proper place to initialize because this is where the API is, right? So, this is a proper place to actually initialize this. So, but yeah, look at that. We've actually removed quite a lot of the squigglies, right? We've gotten quite a lot of those out of the way. Not to say the thing is fixed and working, but it's probably a long ways to go, I'm guessing. And we actually have reference to this now, which is nice. I thought I recoded this. Is there another version of this somewhere that I thought I redid this. Where? I could have sworn I recoded this to not be a switch. Oh, I wonder if I did that. No? I could have sworn I did that before. These errors. Yeah. A lot of this code is going to get commented out. It's not going to be functional. Let me just put it that way. The intention is you are going to be breaking all these blocks, so there should really be no code in here doing anything spectacular. It's really going to be minimum. Basically being able to load the object and not break, but doing nothing else. There's going to be no ticking. There's going to be nothing. But making sure that, you can gracefully load the information without doing too many crazy shenanigans. Okay. So yeah, those errors are going to be there until I get ready to actually compile. I could have sworn this convert index to face. I could have sworn that I had coded this. Definitely not here. Unless there's multiple of these floating around somewhere. Yeah, I could have sworn I recoded this. Did I somehow reverse it? That's what I did. If face index is less than 6, return block facing dot all faces of face index. Else return. Wow. Return. No. Does anybody else remember me doing this? I could have sworn that I did this already once. Okay. That's weird. I could swear. I could swear that I did that. Yeah, it's weird. Yeah, and then this beast, Mark Pipe Dirty. There's a big to do on this. I'm gonna have to go through this line by line and just figure out what the hell is going on. And then the last thing is the Mark Pipe Dirty. The catch for that, right? When we mark the pipe dirty and we give it the list, or if we don't give it the list, either case, we have to detect that on node remove. There it is dirty. So if it's dirty, right, we need to process I don't know. If you're dirty, what should the function be called when you process? Clean with soap.
Only thing I can think of is processed or something.
it's dirty, and once it's clean, then it won't be dirty again. So at the very end, is dirty equals false. So if insert unsorted nodes.count is greater than 0. Whoa, wrong. I fat fingered the wrong key. Okay. So if the unsorted nodes.count is greater than 0, that means we already have some nodes, right? All we need to do is sort those nodes, or how do we want to do this? Because I don't know, again, I don't know when we pass in the list of nodes, is it passing those and giving me a copy of them? Or is it passing that, or is it passing it by reference? And if I edit these nodes, is it going to change it for all of the other nodes, right? All the other extraction nodes. Like if it were in C++, I would know, yes, it's passed by reference, right? I could actually control, give me the pointer, right? Or create a copy. In this, it's like, it's kind of up in the air. If I pass a list into a function for many different objects, do each of the objects get a copy of that list, or a reference to the same list? Pass a reference to the same list. Yeah. Not good. So yeah. Can't do a shallow copy. So I can't create a shallow copy. Yes, the list contains classes and so when I pass that list into somewhere in here is marked no dirty. This right here, it's passing a reference to the list. And if I do a simple copy, it's a shallow copy, so the objects behind the scenes would still be the reference. Um, there's that select. Okay, I think I might, because I'm passing in the list and then I'm clearing it. Right, that's a problem. So if I do a dot select n dot copy dot to list, that's really icky though. It's really icky. It's weird that you can't do like list dot copy or something like that. List dot clone. I mean, I could do an array. Does to array create a copy of the data? To array doesn't creates a shallow copy. Damn it. So it creates an array, but then just adds references to all the items. Yeah, here's the to list. Yeah, this is one of those like each pipe extraction node values requires its own copy of the insert node list, so it can sort and access independently. God, I can't fucking spell or type. Each item requires its own copy of the insert node list, so it can sort and access it independently of all the other nodes. Which is why I needed to be a copy for each extraction node. I love how it. So the select n.copy, that's originally what it said. Hey, this is how you create a copy of this data. And it's telling me now, like, this is an incredibly inefficient way of doing it. And it's like, that would have been nice to know 10 minutes ago. Like, what are you telling me? You're giving me this as the solution. I need it to be efficient. Best readability, reasonable performance. Do the copy once outside, then give each node its own reference. Wait. What? How is that different? So I guess the reference to each node is probably fine. Because the nodes themselves won't change. It's just the list that each extraction node, that's where the uniqueness comes from, is what order those nodes go in. Because each extraction node might have a very different distance value that's calculated. But each insert node, oh my god, each insert node will have unique data in it based on the extraction node, aka each node is a different distance from each extraction node. So if all extraction nodes have the same insert node distance encoded in the insert node, they would not perform properly. I only gave it a tiny snippet of code. I'm a little afraid of giving it the whole file because then it would be like, you suck at coding. Please don't talk to me anymore. So it's only going off of that little snippet. It has no concept of what the objects actually are, right? So you have to kind of, depending on what you're trying to use, the helper for, the tool, it may be way off of what you're trying to do because it doesn't really understand what is going on behind the scenes, right? It was saying, hey, just make one copy of the list and then pass a reference to that copy to every node. But the problem is when that Mark Dirty event happens, it's going to calculate all the distances, right? To all of those nodes are going to be a different distance. So what I would probably have to do is create a copy of the node and make, hey, this is the new distance, and just copy it rather than just change it. Now it's stuck on block position. What the fuck is wrong? Like, oh my god. What the fuck is wrong with this thing? Oh my god, this is just pathetically bad. Anybody who thinks AI is taking over, they're way ahead of the curve. It's not even remotely close to ready yet. It's good at some things, but horribly bad at others. And there are probably people that are much better adept at getting out very specific things, but I've run into issues where it just completely fails on some of the most basic logic. Like, dear God, it's like trying to work with a 2-year-old sometimes, and like trying to get a 2-year-old to help you code, but a 2-year-old that knows how to code but just doesn't quite understand the logic behind what you're asking. It's just like flat information that it can get at and compile and summarize. That's really good. It's really good at taking a bunch of information and summarizing what it sees. But if you're trying to create something and you're trying to say this is the logic path that I'm following, it just goes off into the weeds and is like, oh, this is the solution. It's like, it's funny because it will always give you an answer whether or not it actually understands what you're looking for. It will never ask for clarification on something first, right? Which is a huge problem. Because if you're asking it something very specific, and then it never asks you for clarification, it's assuming you gave it all the information that it needed. That's not intelligence. It's not AI. It's like a really efficient search engine. Unless it says, hey, I see you're trying to do this. Can you clarify something for me? Can you tell me what this object is? Right? What is this object doing? Or what are you trying to do? Or what it like, it never asks you for clarification. It never asks you for more information before vomiting a bunch of shit to you that doesn't make any sense because it doesn't understand. Right? There's no understanding behind it. It's just like, blah, here's a bunch of shit without any sort of like, hey, I don't quite get what you're doing here. So it's just vomited out a bunch of shit that was like, no, this is not really what's going on here. And then sometimes it gets like, it mentioned block position in like past, and now it's like stuck on block position. It's like, oh, block position, and it's like all of my data is now block position. It's like, where did that come from? No. Ignore that shit. We're dealing with something else here, right? So I think what I'm gonna have to do is I'll just pass it the insert nodes. Okay. Now the insert nodes are going to get passed to the Mark Dirty. So now we need to go to the Mark Dirty event. And rather than go, hey, insert nodes, do this, right? I want to then go list of pipe insert node t underscore nodes equals new list do I have a position here? This dot position, I do. So what I want to do is I want to then encode a copy, right, of the nodes with the proper distance involved. So I want to do t underscore nodes dot add new pipe insert node, and now I want to encode the position here, including the distance for each pipe insert node node in node list. Okay. We want to do a dot add node dot position node dot facing node dot subnet, and then distance will be position dot Manhattan distance to node dot position. Okay. So that is the block that it is connected to, not the position, right, of the node. It's the position of what I am connected to, right? Manhattan distance, anybody who's not familiar with that, it's also kind of falls under the taxi cab geometry. So if you think about it's kind of intuitive, taxi cab geometry. It is the Manhattan distance is like the difference of the X and the Z and in this case also the Y. So it's like what is the distances, right? If you add up all the zigzags, what's that distance? So if you're 3 blocks out, right, 2 blocks over and 2 blocks up, it adds all of those individually and gives you that distance, right? Which is the same as if it was straight up that amount of distance, right? The Manhattan distance is kind of it's a way that you can differentiate the differences of distance very subtly, right? You're going to have a lot of blocks that are going to be the same distance, but in general, it's going to be pretty close to what distance it is. Because you could, in a pipe, you could run, let's say you have an extraction node and you run a pipe way down, go over, and come all the way back, right, to connect at a block 3 away from where you started. But the pipe goes all the way down and all the way back without any other connections. Well, that Manhattan distance is going to be from this block to this block. It's not going to count the distance around all of the pipes. It's going to be this block position and this block position, right? So somebody who is trying to manipulate the pipes, right, the order of operations, like what chest is hit first, and they go all the way out and all the way back, it's going to hit the closest one first, right? Because if I would have to know how many damn pipes there are to get to that point, which would be a monstrous amount of data that have to sync and store. Because I would have to keep track of, okay, I'm this block, like how many pipes there are. Yeah, you can do that, but that's a huge amount of processing that you have to have for every single thing. Sorry, but it's just not going to happen. So this is creating a new insert node, right, into this. And then at the end, we want to say unsorted nodes equals T nodes. Okay. So our unsorted nodes now include a distance. They're still unsorted, right? But now it's a copy of the nodes, and we encode a distance into the copy, right? The new, we pass it the position, we pass it the facing, we create a copy of that data, and we then generate the distance, and then we add that to the list, and that's our unsorted nodes, and it's still marked dirty. This marked dirty, which doesn't have a thing, extraction node marked node dirty is an apply upgrade. Okay. Pipe extraction node mark node dirty. So this will be unsorted nodes equals BE pipe base new dot build insert node list API dot world position. And if we go to that function, can we encode a distance in the thing based on the given block position? Is there any reason to run this in any other spot other than where we are? Insert node list, an extraction. It's almost like this function is, if we're a known extraction position, where do we want to build the list from, right? So I think we can encode the position from position dot Manhattan distance, and we want to do basically this. That's a lot of parentheses over there. So this is encoding from this position, which never changes, right? The from position, we're not editing that at all. And then we're calculating the Manhattan distance to the position that we're adding to the output. And that way, when we return the output in here, it's already an unsorted list. Right? We're marking it dirty, and now we have an unsorted list. All right. So then it's just a matter of like processing the unsorted list, which I called clean with soap because it's, you know, we're dirty. We don't want to be dirty anymore. So unsorted nodes.count is greater than 0. We want to say insert nodes. Well, let's do if insert nodes.count greater than 0. Insert nodes.clear. Push enumerator.dispose. If insert nodes.count is greater than 0, insert nodes.clear. Insert nodes equals unsorted nodes.sort. Ah! I never x colon y x dot distance. Oh, x dot distance dot compare y dot distance dot to list. Ah! Why you not like it? I guess it's already a list. I'm sorry, what the heck what is going on right now? Why is this not working? Um, oh. array.sort. Okay, why am I know I did this sort somewhere. Why is this? I thought this was the syntax. Unsorted nodes dot sort. Oh. Okay. Order by. Do I want to check? Counter or array.sort counter array. Oh. Really? I'm converting this into an array when I do this? Why do I do that? But every tick I'm doing this? That doesn't seem right. Still going to be by distance, but farthest first. Now, there's another edge case. My life is edge cases, by the way. It's crazy. What happens when you change the pipe distribution mode partway through? what is run and what is called. If unsorted nodes.count, okay. I need to pull this. Yeah, I'm gonna do this. Cut. Paste. If unsorted nodes equals null or unsorted nodes.count equals 0, unsorted nodes equals pipe build insert node list, push enumerator dot dispose. If insert nodes.count equals or greater than 0, clear it. If unsorted nodes.count is greater than 0. Oh my god. There. There. Whoa, 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 whoa. Don't auto add brackets. Right? So if we don't have any unsorted nodes to process, grab them. But even grabbing them, there might be 0 nodes, right? You might not have any nodes. So this could be an empty list, right? It could be zero items in it. If so, that means we got rid of all of the insert, we got rid of all the insert nodes for now. So we need to remove the enumerator. We need to remove the insert nodes that we have because we have some in error, but we don't have any unsorted nodes. So if unsorted nodes.count equals 0, we've already cleared this list. We don't need to do anything else. But if unsorted nodes.count is greater than 0, then we want to process them. And if it's 1, there's no point in doing order by, but it is what it is. Like there's a single item in there, it will be fine. And then we remove the dirtiness. But yeah, that's gonna have to do it for today, everybody. I went way longer than I thought I was going to. I just kind of got into the weeds here. But yeah, I'm getting hungry. I'm actually very hungry. But I want to thank everybody for coming by. Not a whole lot of people stopped by today, but it's always nice. It's always nice when people are around and hang out. So now is the time when you're watching a dev stream, it's the time to ask pointed development or mod development questions. So when I get done with the stream, I usually look at the Vintage Story mod development forum, and there's a bunch of people asking questions in there, and I'm just because usually I post the stream in there too, but it's asking those questions, a lot of those questions that people ask in that mod development forum, it's this is why I do these streams. Come and ask questions. I want to encourage people to learn how to do this stuff. And if you're stuck on something, I can show you not only how I get the answer, but usually I can find a good answer. There's some things that are out of my realm of possibility, but I try to answer questions. But anyway, thank you all for coming by. Come back on Saturday where we're gonna do whatever we're gonna do. I don't know, maybe more EU4, EU5, something like that. But stop by then. Otherwise, have a great rest of the week. Stay warm, and hope to see you back here on Saturday.